So now you guys can see, you know, the SQLAlchemy logo. So let's see what time, 9:02. So there's a lot of material in this thing, and in the past it's taken me a long time to get through, and I have to rush. So I'm going to try not to rush too much. And the material is all, you know, on the GitHub. If people are in the Slack, I put the link to the GitHub that has all the material. So if my entire thing blows up here, you can always just go read all the content on GitHub.
Mm-hmm.
I wanted to point out to people that when you do download SQLAlchemy, you actually get a free Space Invaders game. So people should see a black screen here. And this is actually a Space Invaders demo running with SQLAlchemy. And you might not know what you're looking at. This is an ASCII art Space Invaders. And if you guys can see to the left of my shooting these spaceships, there's a whole lot of SQL going by. And that's because this Space Invaders game actually stores all of its state in a SQLite memory database and is using the ORM to save and retrieve the coordinates of all the glyphs on the screen. So I wrote this a long time ago for whatever conference I was doing. And if I can get through this screen, then we can actually start talking about SQLAlchemy. So when you download, there's actually an examples folder. And this is the one example that if you were to read through this, how this example works, you would pretty much get the entire Zen of the SQLAlchemy ORM. And that's how that looks. And there you have, because it's using curses, it's all messy. So you can see over here, there's a whole lot of SQL that happened in the logs. It's just doing a lot of select queries where it's just getting ranges on coordinates and things like that. It does it fast enough that you can actually make a game out of it. So if anyone happened to like what I just showed, you so usually when I do these talks, I'm in person so I can see people. So now I have no idea if people enjoyed that or didn't enjoy it. Is there a clap button in the
There
for
is,
anything
yeah.
like there is something like, okay, so go to the slides. So the way this talk works is there's some slides that are not really, they're introductory, they're just quick to get you oriented. And then after the slides, then we go to this part where there's a lot of code examples that we're going to run through. And then we go back to some slides. So here's the slide. See if this works. Prerequisite knowledge. When we do this talk more formally, there are some things that are good to know that would make the talk more understandable. Basic knowledge of SQL and order of importance. If you know about create table, how tables work, columns, querying, rows with select, modifying data with insert, update, delete is good to know. The general idea of a transaction is good to know. And joins, SQL joins, grouping, not that important for what we're talking about. Just things that I'm going to be showing how to do in SQLAlchemy, and if you don't know what they are in SQL, it would make less sense, but you can always review later. Overview of SQLAlchemy. I need to make sure I'm looking at the time. So for this, we have till 20. We call ourselves the Database Toolkit for Python, introduced 2005. It's an end-to-end system for working with Python database API, relational databases, SQL language. You'll notice that I change how I pronounce SQL between SQL and SQL. I tend to say SQL, but I think SQL is probably more correct, so you're going to see me just switching. We're currently on 1.3.17, and 1.4 is the version I'm working on quite a lot, and that's considered to be what's I'm calling a transitional version to SQLAlchemy 2.0, which is basically the Python 3 only version with a lot of other rethinks of some fundamental assumptions. Goals of SQLAlchemy: provide helpers, tools, components to assist with and automate database application development. Provide a consistent, fully featured facade over the Python database API. Industrial strength, but optional object relational mapper. SQLAlchemy is not just an ORM. We've always made sure that we're not just the ORM. If you don't like ORMs, you don't have to use it. Act as the foundation for any number of third-party or in-house tools. Boop, boop, boop. Philosophies. Bring the use of different databases to interface as consistent as possible, but expose the distinct behaviors and features of each backend, and they all have that, especially Postgres probably has the most crazy features, and we try to expose them, and we try to let you use a database to the full extent that that database allows, while still having the majority of your code be agnostic between different databases. We don't hide the database. We're not about the idea of an abstraction layer hiding the database. You need to know about SQL to work with SQLAlchemy. What we're trying to do is provide an automation layer. And DRI means don't repeat yourself. And then we're trying to favor declarative and compositional patterns over flags and switches whenever possible. And I think that'll just be, you'll see that when we do some code examples. Hopefully there's not too much prevalence of one big function with lots of flags. You're going to see more compositional, X becomes Y becomes Z. So it looks a little more natural. And we really want to stay true to SQL. And this is something that other tools don't necessarily stress as much as we do. We don't want to invent a new query language or relational paradigm. We really want, when you work with SQLAlchemy, to feel like you're working with SQL just in this way that's more automated and less boilerplatey. This diagram is on the website, so people who've read the docs have seen this is what you call a pancake diagram, because you have these different layers sitting on top of each other. The highest layer is the object relational mapper that builds on top of SQLAlchemy core. Core's major components are schema, SQL Expression Language, engine, connection pool, and dialect, and then all of that talks to the Python database API, which is your driver, like PsychoPG2 or MySQL client, PyMySQL, CX Oracle. Then bullets for those things. Engine is a factory for database connections, which are maintained by a pool. The dialect sits underneath the engine. It's hidden, usually. And it's the thing that knows about, you're using MySQL, you're using SQLite. We know about how to generate SQL for that. The connection pool, is kind of basically where connectivity is maintained. It's not necessarily a pool. It usually is a pool that stores connections in memory. But the examples today, we'll be using a pool called a null pool, which actually doesn't pool, it just connects and disconnects each time you use a connection. SQL Expression Language, we use Python to create SQL queries. The schema system is using Python objects to represent DDL concepts, tables, columns, data types. And then on the ORM side, which hopefully we'll get to near the end of the talk, probably about, 11 o'clock is when we hope to do ORM. Maybe a little late there. Construction of Python objects, which can be mapped to relational database tables. So basically, this is where you're creating business objects, like your official banking application or whatever you're doing. And then your objects have data that's in the database. They can be persisted. Someone's got a microphone on with breathing. Transparently persists objects into their corresponding database tables using the unit of work pattern. Provides a query system which loads objects and attributes using SQL. That comes from mappings. The ORM built on top of the core. And it presents a slightly more object-centric perspective as opposed to a schema-centric perspective. Sometimes I have to move. You might not see, I have a little Zoom group chat and I have to move it to see the end of my slide, but we'll work with that. And then I got to change the focus. Quick other subsystems that we're not going to do much with in the talk here, but they're there just to know about. There's an event system, event hooks throughout SQLAlchemy to tell when things are happening. You can modify how things work. The inspection system provides insight into various objects like engines, mapped objects. The SQLAlchemy extension package is a lot of extensions, mostly ORM related. If you're writing a third-party dialect for another database, a lesser used database or some other database that's not included, there's about 20, 30 third-party dialects on the site now. You would want to use the SQLAlchemy testing package. It has a compliance suite, so your test suite would be using this suite. And there's a SQLAlchemy.examples folder package that has an in-depth performance suite, and it's also where you get your free Space Invaders game. So rush right out, get your free Space Invaders game. So The big thing I'm working on, and it was kind of inspired by Python 3, Python 2 being retired, you know, and Python 3 having a lot of great stuff. 1.4 and 2.0, the standardization of Python 3, SQLAlchemy is on the path to an all-new 2.0 release. Major features, streamlining of APIs, and it's going to be a pretty deep cut into pretty much every legacy pattern that has ever bothered me. A lot of the patterns in SQLAlchemy still date back to the 0.1, 0.2 days when we had a completely different way of working. And, you know, we changed the APIs pretty dramatically, but we still kept things around from the earlier ways of thinking, and it's time for those to just go. So when you upgrade to 1.4, your code that runs SQLAlchemy now in 1.3 will continue to work for the most part. There's a couple of, if you have some internal extension stuff that might change a little bit. 1.4 works like 1.3, but it has all the 2.0 APIs present within it. Sometimes you'll have to import from SQLAlchemy.future. I'll show that how that looks. And then you can have the 2.0 version, and there's basically then there's a deprecation mode so that you can migrate your application to be totally 2.0 style. And then you can migrate, hopefully by then SQLAlchemy 2.0 will be in beta, and then you can try 2.0 and you'll have, I think, hopefully much more readable code, faster code, because it includes caching. Major changes for 2.0, it'll be Python 3 only. We're still doing Python 2 for 1.4 because we're nice like that. People still are straggling on Python 2. Engine is going to get very refined. The engine level auto commit will be removed, but there will be another way to do auto commit. Connectionless execution is removed. The result set is very refined. It's got many new features. Rows are completely tuple-like, and a lot of nice stuff with results. The vast majority of SQL compilation is going to be cached, meaning that when we generate the strings, all the Python overhead of that is usually going to be cached for most of the regular bread and butter SQL statements. The ORM query is now, this is actually in master, this has been committed, is unified with select. You can actually use a select object instead of query to get ORM rows. And as far as if ORM query goes away entirely, that's still a little bit up for grabs. But technically ORM query won't be needed. You can use selects. And then also when you use selects and use all the new style, you get back the result sets for both core and ORM queries and all of the same ability to slice up rows and uniquify them or get certain columns only, get scalars. There's been a lot of requests for more flexibility in how ORM results are returned, so this will give it to you. This is the onion diagram. This shows the 4 components of SQLAlchemy, or SQLAlchemy as I usually call it in my head. These colors actually match to the colors in the first pancake diagram. You know, these are the 4 main components, and we're going to start from the inside. Let me see how the time is going, see how long I'm talking. Okay, so I'm going, this is good. I'm speaking fairly relaxed, and I'm actually ahead of the game. So maybe we'll have time to get through all of the material. And also, I'm assuming people are going to, I'll see questions in the chat if people wanted to, you know, had any curiosities about anything. And so, level 1 is the green circle, the engine, connection, and transactions. And then first we'll have some top level. What is SQLAlchemy engine trying to do? Well, the first thing we have to deal with is the Python database API, which is PEP 249, which is the system that most people use for providing Python database interfaces. There's lots of them. Most databases have more than one. They're very, very different, even though there's a spec. The database APIs are super, super different from each other. And this is what a DB API looks like. This is the PsychoPG2 DB API, which is pretty popular. It's got some performance issues, but it's the one most people use right now for Postgres. There's some others that are more async IO oriented right now. There's actually a PsychoPG3 in the works that will also do async. But for now, a DB API looks a lot like a connect, where the arguments are kind of open-ended for different database APIs. You want to get a cursor to work with SQL. The cursor is also how you fetch rows. The cursor represents an active, resource, so you want to close that at the end. And then the connection itself has a commit method. So Python database API does not have any auto commit turned on by default. So this is not SQLAlchemy. This is the Python database API that SQLAlchemy is going to internally use in order to do things. Important DB API facts. The DB API by default is not auto commit. There's always a transaction. You have to call commit or rollback when you want data. You have to call commit when you want your data to go in. Database APIs achieve this by employing an auto begin, meaning when you first run a statement or first connect, sometimes depending on how they want to do it, a transaction is begun and it's open. Most database APIs now have an auto commit feature that turns this thing off, and SQLAlchemy supports that. There are 6 different bound parameter formats for database APIs. Bound parameters are obviously, well, if you don't know, they're not obvious, but they're very important to use because that's how you take numeric dates, textual values, any kind of user input, and that is part of a SQL query. You want to put it into a bound parameter so that the driver can make sure that that string is sent to the driver correctly, and it's also safe stringed. It removes the possibility of SQL injection attacks. It also has a lot to do with coercing the typing information, like a date needs to be formatted in a certain way, or a binary needs to be sent in a certain encoding, things like that. But the Python database API decided to have 6 different formats for no reason I can imagine, and it's kind of inconvenient. And as I already said, they have lots of inconsistencies, and in my opinion, it's not possible to write non-trivial DB API agnostic code without using libraries. Meaning, when people say I'm just going to use a DB API, well, fine, you're going to be hard coding to a certain database for sure. Anything non-trivial, because they're all very, very different in how even simple things are done. Quick sample API consistencies. They all have different. I mean, there's a standard exception hierarchy, but you have to import those classes from that module, so it's not easy to catch an exception in an agnostic way for 2 different database APIs. If you want SQLite, there's no date time. You have to turn them into strings. Other DB APIs will take the dates. If you're on PyODBC with SQL Server, you might find that sometimes your index don't get used because Python 3 Unicode strings are going to force it to use nvarchar for some data types. What is the artifact of Mike's screen? Oh, is that the group chat? Is it in the lower right?
Yep.
Oh,
yeah,
so how?
So I need to be chat.
Right. So I'm looking at the chat so people talk to me. So I'm not quite sure how about if I just do that, just so I can. Is that, yeah? Where should I put it? Yeah. Is that better?
It's better.
All right. I mean, because if
So,
you're talking, this is literally, I see like a few people, and then if anyone's talking to me, I won't know unless I see you coming up in there. So, yeah, this is the technology, and then I got to change that. Encyclopedia 2's execute many is slow, and there's some special steps to make it faster. You just wouldn't know this if you're just coding to the DB API in an agnostic way. Ain't it fun? Yeah. CX Oracle is totally crazy. You have to do so many things to make it act normally. It's just nuts. I didn't want to get into it. MySQL drivers, row count decides to, and the people who work with MySQL probably know this, that row count is different on MySQL. There's special flags to change it. This is not important for anything. It's just to show how there's all kinds of silly details that are going to be different with different database APIs. So what is SQLAlchemy doing with the DB API? I want to see what my time for this section is. 9. Okay, good. SQLAlchemy's first goal is to tame the database API, conferencing in 2020. Provides a consistent URL-based connectivity pattern. Anyone who's already used SQLAlchemy knows this. Extensible type system. This is a big deal that people don't notice, but it is very complicated. When you insert rows in a database, usually, not always, but often you have integer primary keys that auto-generate from a sequence or auto-increment or identity. the act of creating that new identity and then getting it back from the row is this completely crazy thing that is totally different on every driver. I mean, it's not totally, but there's different techniques that you need to use for different databases and different drivers. And SQLAlchemy is one of the very first goals was to normalize all that. And it's just a complicated thing. Single bound parameter format, fixed exception hierarchy, but we don't have the same messages. So if a certain database spits out a certain exception message, it's not going to be the same as a different database. There are ways to normalize that too, but that's not part of SQLAlchemy. And then when we come to this slide that has this slide REPL thing, that's where we go to the slide REPL thing. And if I can get to there, so now you guys should see a terminal window. So this is what it looks like when you create a SQLAlchemy engine. Anyone that's already used SQLAlchemy has done this because this is basically ground zero for how to get to your database. And there's a URL for SQLite here. If you were connecting to other kinds of databases, there'd be like a host name. It'd be like, MySQL Scott Tiger at host name, database name, like that. Those are another kinds of URLs. When you do create engine, it didn't actually connect to anything. It didn't create any socket connection. It didn't open the SQLite file yet. It just basically verified that your URL makes sense. It loaded up a driver. It loaded up a dialect, SQLite dialect. It has the pool inside the null pool, which hasn't done anything yet. So it hasn't connected yet. It's just kind of set up what you're going to be doing. And then, for the purpose of these slides, they're going to see this in a couple of things. There's this thing called future. And this is where I'm going to also try to show some differences between the 2.0 style of doing things and the 1.x, we'll call it, style of doing things. There's a package called SQLAlchemy Future that's in master. It's not in 1.3. It's only in master, which will be version 1.4. And it has basically a create engine function and it has a select function in it. That's all it's got, 2 functions, and that makes all the difference. So we're going to make another engine that I'm only going to refer to a little bit, which is the future engine. Basically, it's from SQLAlchemy.future, import create engine, the same create engine with a little flag set on it, basically. And we'll call it future create engine. And we'll make a second engine that's called future. And the reason I'm doing this is so that later when I show you how to get result sets, I'll show you the slight little differences between the 2 engines. Does that make sense to people that there's 2? See, I wasn't sure if I should be introducing this in a beginner tutorial, but I also wanted to kind of show people who know this SQLAlchemy, here's the 2.0 stuff. So if people
future is 2.0.
Yes, anything that's future is 2.0. However, this package will be in SQLAlchemy 1.4. And when you're in
the future package will be in 1.4.
Yes, the future package will be in 1.4. And then when you go to 2.0, the future package will still be there. However, that'll be just a synonym for just import SQLAlchemy.
Understood.
Does that make sense? It's a little weird, right? The thing is, the future packages ended up being so small that I might not even do it like this. It's literally 2 little things. So maybe I'm not going to have. But for now, this is how it. If you get master from GitHub and you want to use the future stuff, this is how you get it right now. So yeah.
Cool.
So back to our normal engine without the future stuff. Now we're going to actually connect. So now we have this object called the SQLAlchemy connection. And what's happened is we actually have made a SQLite connection using the PySQLite driver. In Python, it comes packaged as SQLite 3. It's a Python built-in library. The connection is a facade around the SQLite connection or a proxy. If you want to see that, you can say connection.connection.connection. There's 2 of them. Connection is the SQLAlchemy connection that we'll work with. Connection.connection is this little magic object that you don't need to know about called the connection fairy, and people who have debugged SQLAlchemy applications have certainly seen this in their tracebacks. It's kind of like a little wrapper that tracks when the connection goes out of scope. And then connection is SQLite, and that's your actual, yes, fairies, SQLite connection. The reason it's called a fairy is that it was meant to be kind of an ephemeral object that when you connect to the database, there's this little wrapper thing that has a weak reference to it, and then it just kind of magically vanishes. and that's what it's called. Anyway, yep. So one thing that happens in SQLAlchemy 2.0 is that we don't let you send a straight string straight to execute anymore. Over the years, there have been very few people who are upset about strings being passed to certain places, and we want to make it very clear that when you are sending a string to the database, you know that you're sending a raw string to the database so that there's no chance, we hope, that you are taking your string from someone's web form and having them own your database. So when you want to execute a string, the correct way to do it is to use the text construct, which will also normalize the bound parameter format. And we say statement equals text select emp ID, emp name from employee. I should also note that this slide runner thing actually created some tables for us, and that's why this is going to work. The SQLite database has a table created already. And then, so basically I have this statement called from SQL import text, create a statement object with some string in it, and then we're going to execute it. We're passing a parameter of 2 for emp ID, and then we'll get a result back. And then when I press return, you'll see SQL logging. That just shows what we just did. One thing to note is you notice the bound parameter in the executed SQL is a question mark. That's called QMark format. That's one of the 6 database API formats. So SQLAlchemy, in this example, converts from its internal colon format to question mark, and then you see that. So far, so good. When we have a result object back, it acts a little bit like the Python database API cursor. It has methods like fetch1. It has rows that come back as tuples. They're actually not quite tuples. They're first and foremost, they're named tuples, meaning the names of the columns are in the row as names you can access, and they're actually here with keys. So emp ID and emp name are the keys. And this is actually the first place where something is changing in SQLAlchemy 2.0, is that they're going to be even more like tuples. Right now, for SQLAlchemy since 2005, if you have a row, you can also use it as a dictionary, like this, a row with dictionary brackets, and then the key name. And the problem with that is that's what we call Python dictionary or mapping. It's not actually fully compatible with being a tuple in every way, shape possible. So you can always use name tuple, because as people might know, Python has a built-in class called name tuple, where you have a tuple that has 0, 1, 2, 3, 4, any number of elements in it, and then you can access them by name like it's an object. That's fine, but when you do the thing with the brackets, it's a little more controversial. Let's check the time, 10 minutes. And I'll show you why in a minute. So in SQLAlchemy 1.4, when you can, the old version will be deprecated in 1.4, but when you want to do it the new way, and you want to use a string name for a column name, you do _mapping first to get the dictionary view of the row. If you don't do mapping, you're on the tuple view of the row. And then 2.0, this will be strictly, oh, my phone started talking to me. Thank you, phone. So that's that part. And then what happens is you have the name tuple. So it's our first 1.3 to 1.4 future migration note, is that in 1.x and the 1.4 deprecated version, the contains method of this tuple, which in Python is how you implement the in operator. People know about like x in y is implemented using a method called dunder contains. If people have no idea, whatever. So what the row does in SQLAlchemy Classic since 2005, and this is straight up my stupid mistake, it looks for the keys of the columns, the names of the columns in the row, which is actually kind of useless because you've already done a select statement where you know what the column names in the row are. So it's kind of silly that it works this way, and that's why row emp, emp name in this format is also kind of incompatible, because if you assume row bracket emp name returns a value, then you would assume emp name is in row. But it's a tuple, and it really shouldn't work that way. So in 1.4 future, if you use your future engine, it will reverse this. So that emp name is not in the row, and it's actually the value Sandy is in the row. So that's kind of a change that is small. It's not hard to make on the code on the SQLAlchemy side. It's easy for me to make the change. But if there's some big application relying upon this, yeah, it could be a huge deal. So we're making this really gentle upgrade path that, by the way, this is what happens. So far, so good. How's the time? See, now I'm running out of time. The result object actually has a cursor inside of it. So it does have a resource that can be closed. The result normally closes the cursor automatically in almost all cases. You normally don't have to call result.close. But it's there in case you're doing something like cutting off your results, which you wouldn't normally do. You can iterate a result. You can just say connection executes, star from employee. People might notice what the subject of our sample data is today. These are characters from SpongeBob SquarePants. We'll be working with SpongeBob, Sandy Cheeks, Squidward Tentacles is his full name, and Patrick will be making an appearance as well. You can do fetch all, which is another DB API method. Same thing, gives you a list. And then in 1.4, there'll be more fancy methods. I'll have some more of these later. I want to get just the emp name column by itself without using tuples, then give me all of them back so I get just a list of strings. And this also will apply to the ORM because the ORM will also give you this result object. So you can do all kinds of slice and dice things that I think people will appreciate because they've been asking for it. Connection itself has a close method, and this is a more important method. This does a thing that we call releases. It means it doesn't actually necessarily close the database connection. In this case, it actually will because the SQLite database is not using pools. But when you use a connection pool, releasing the connection means that you are no longer using this connection. It can go back to the pool and be put back in the connection pool to be used again. If the connection pool is configured such that it's already full and it doesn't need this connection, it'll close it. If the connection pool is configured to have infinite connections, then it won't close it. If you're using the pool we have here called the null pool, then it will close it. The point is, when you say connection.close from the SQLAlchemy engine side, the connection is released to the pool so that the pool can choose to manage that connection in whatever way it's programmed to, and you don't have to worry about that at the programmatic level. It's more of a configuration time thing. Now, you probably won't be calling connection.close because in modern SQLAlchemy, modern Python, you're going to use a context manager. Now, I was just talking on the Slack chat with Paul Everett, and we were talking about how SQLAlchemy in 2005, Python was really different. Context managers, meaning the with statement, were not introduced until Python 2.5, and SQLAlchemy was running on Python 2.3. So we had a couple of years before we even had the ability to have a context manager. So a lot of SQLAlchemy's patterns were not well formed to context managers because it was a thing that was added to Python later. But nowadays, we should be good. If you want to use an engine directly, you want to connect and you want to do something on a connection and then close it, you should use a context manager. And then also you might be noticing in the log output, this is something that will become more interesting later. The log output from select star from employee is showing that that statement was actually cached, which is meaning not that the results were cached, it means that the string compilation was cached, which in this case seems a little funny because we already gave it the string exactly. But later you'll see there's other kinds of objects that are not strings that get cached. So look for the log output to see that happening. Someone asked a question. Will the result object close if it goes out of scope? Yes. It will close, yes, because the cursor goes out of scope and the database driver usually has the idea that the cursor will close when it goes out of scope. The connection in modern SQLAlchemy will not go out of scope. If you were to drop the connection also, the connection pool has logic that will receive the connection and be like, oh, you lost scope to this thing. It uses a weak ref callback, and then it will return the connection to the pool automatically. However, this is an anti-pattern. You should always make sure things are handled probably by context managers. Make sure things are closed. When you let the garbage collector do things, you have problems like other threads do GC collect sometimes, and it's not a good idea. So we're probably going to be having warnings popping out when you don't close your connection and the pool grabs it. Cursors are less interesting. They're not. They tend to not even be real objects in some database drivers, so it's not as critical. But yeah, for scoping, it's definitely better that things are explicitly cleaned up in the way you write your code. So context managers and fully exhausting your result sets is the best way. If the result set does not return any rows, like it's an insert with no rows returned, the cursor will be closed already when you get it. So the cursor closing is pretty foolproof, mostly. Should a connection object be global? No. Connection object should never be global. So the question is, should a connection object be global? The thing that is global is the engine. The engine is the factory for connections. So you make the global engine, and that should be a global object. And then when you want to do something with the engine, you want to do some work with your connection, you have to think in terms of, I mean, it depends on what kind of application you're writing. If you're writing a console script that's just going to basically run through a bunch of data and be done, then maybe you could have the connection be global. Otherwise, you generally want to use the connection kind of like a file handle. Like in Python, you don't want to open a file and leave it open throughout the whole program. You want to open the file, read the data, and then close it. You want to open the file, write whatever you're writing to it, and be done with it. So you should try to limit the scope of connections to hopefully not be global. Using a context manager is a pretty good way to have it visually displayed what your scope of things is. 18 and 25. Okay, now I'm falling behind. So, yeah. Some work on auto commit. So DB API does not have auto commit. SQLAlchemy has implemented its own auto commit that we're going to be changing. If you run an insert statement like this, there's a regular expression that tracks the insert, and you can see in the logging when I run that statement with connect, it does a commit. That's going to go away in future engine because it's an ANSI pattern, and people usually will run lots of statements, and they're all auto committing. And they don't realize it, and it's not efficient. It's not a good way to do things. And I think I've come to realize that the way the DPI was designed, that commit is not automatic, is a good thing. If you want true auto commit, you should use the database level auto commit, which is a different option in SQLAlchemy. I'm not covering it here. If you want to do a bunch of things with true auto commit, there's a flag that you can use to set that on. But when you work with the engine normally, it will not be auto commit. So the future engine has a little commit as you go method right on the connection, which is not there in current SQLAlchemy. And if you want to explicitly demarcate where you're beginning committing with a connection, well, first of all, you can begin right from the engine, and this is probably the best pattern to use if you're running a bunch of transactional SQL. With engine.begin as connection, then run some stuff on the connection, and you do that, and then you can also run a transaction in a context manager from the, well, there's no context manager here. You can run a transaction from the connection itself. So connect as connection, and then you say trans equals connection.begin, and then you can do some things and commit it, or you can roll it back. You see here's where Patrick becomes an employee, and he tries to become employee of the month, but we roll it back. I'm moving a little quick because I'm falling behind my time a little bit. So this, you know, so there's the SQL for that. So far, so good. Some more of context manager stuff. If you have your connection with engine connect as connection, you can say with connection.begin as trans. This is the best pattern if you're doing it like this. If you want to run multiple transactions on the same connection, run that. Running it is kind of trivial. This is a thing called a nested transaction, which is how we represent a save point in SQL. Let me just pick up my schedule that I just dropped on the floor. Okay, in SQL, a save point is like a named marker inside of a transaction that you can roll back in the middle of a transaction. So you can have a transaction that's partially a bunch of stuff that you put in, then you make a save point, and then you can roll back things subsequent to that save point back to that save point. So it really ends up acting like a nested transaction. So we call that begin nested. So here, there's two examples of begin nested. We're going to first do an explicit begin nested and then roll it back. And then the second example, we're going to use begin nested as a context manager. One thing I forgot to note about these context managers, when you use a transaction in the context manager, when the when the context manager completes, it automatically commits the transaction for you. If the operation you're doing throws an exception, the context manager will emit a rollback for you. So that's kind of the important thing about context managers is that unlike the connection manager, which will only make sure the connection is returned to the pool, the transactional context manager will also roll back the transaction if anything goes wrong. So here's save points. And you can see here that save points have a name. So when it runs, SQLAlchemy creates a save point, SA save point 1, does some things, then rolls back to that save point. Everything that happened there is gone, but we're still in the transaction. Then we do some more stuff on save point 2, and then we release that. So save point 2 actually is part of the transaction. Then we commit, and the data goes in. So that was the engine chapter. Is there anything else that we want to, any other questions we want to do on that before we do the next part of this? So I'm basically watching the Zoom group chat. So I don't know the level of programmers that are on here. I mean, this is an intro to SQLAlchemy, and it was originally for people who know nothing. So the question is, do you recommend building to future at this point? So 1.4, I'm hoping that betas will be happening by the end of the summer. I've got most of the hard stuff done. So when 1.4 beta comes out, I hope people will try the betas and they will try experimenting with the future stuff. So when 1.4 goes final, which will hopefully be sometime in the autumn, then people will upgrade to 1.4, and then you should have fun with that. Then the next thing is make sure your application is totally on Python 3. And then when you're on Python 3, then you can begin migrating to the future stuff, which by then should have had a lot of critique and people, correcting what we're going to do. The migration notes on the website for 1.4, which are already live on the site, have a lot of information on how this upgrade process should work. So right now, 1.4 is still very much under development. I have been working on this stuff for over a year, but it's under development. So I would encourage people to play with it in master if you are feeling experimental. Yeah, so this is verbose. Yeah, so build a future probably when 1.4 would be what you want. I mean, you certainly want to look at 1.4 at future and see what's going to look like. If you see any major issue you're going to have with it, let us know so I can think about, because there are some changes that I'm not sure I want to do. I don't want to get into it here, but there's certain things that, certain decisions that are going to be inconvenient either way. This is the things that are going to be inconsistent in one direction or inconvenient in the other direction. So we've got to decide between consistency versus convenience for a few things. Anyway, we'll move to the next section. And then after this section, SQL Part 1. Okay, so we have 2 more sections. So that slideshow is over. Then we go back to the slides so I can introduce, well, there's some more engine stuff actually here. I forgot. No, level 2. Okay. Level 2. Now we're on the blue circle. So now we have an engine. We know how to connect to the database and emit SQL. Table metadata, reflection, and DDL. Just check something here. Is that on? Yep. Okay. So what is metadata? I got this name from Martin Fowler, who wrote a book called Patterns of Enterprise Architecture. It describes the structure of a database, like tables, columns, and constraints in terms of Python data structures. It serves as the basis for SQL generation and object relational mapping. We can create table metadata and generate a schema, meaning we're using DDL, which is called data definition language. We can also take an existing database and introspect the database, and that will return for us Python metadata objects. And it forms the basis of migration tools like SQLAlchemy, Alembic. So let me move the square. There's Alembic. You can see the word Alembic. That's our migration tool. Click. And then we can show some metadata stuff. Should I go O2? So this is what it looks like when you define the metadata for a table in your database. It intentionally looks a lot like, stepping away, okay. It intentionally looks a lot like a SQL create table statement. It starts with the table, the name of the table, and then the columns are set up in a list. It's meant to look like a SQL create table statement. So here we have a couple of data types, integer, string, and there's also this object called metadata, which is actually a collection. Metadata will be a collection of table objects and other things too, but mostly tables. And so as you make each table, you tell it, hey, I'm going to be called user, and I want to be part of this collection called metadata. And metadata is basically a place that we can manage a group of tables. When you have a table object, you can look at .name. You can look at the columns, which are available from an attribute called .c. So that's the column object that we just created, and it's inside the table in this associative array under .c. .c can give you the list of columns. It's kind of like a dictionary, but not totally. It's a namespace. When you have a column itself, you can look at the column's name. You can look at the data type for the column. And the table also has things like primary key constraint. It has indexes on it. It has, constraints, uniques, foreign keys, sequences sometimes are associated with the table, although they're not part of the DDL for the table itself. When you have a table object, you can do things like create a select statement, and we'll do that more later. This is a preview of that. You can take a table and send it to this construct called select, and you get a select statement when you print it or send it to the database. Now we're going to create the table. So we have this metadata. We say, hey, metadata, create all the tables using this database connection. And we use a transaction because a lot of databases have what's called transactional DDL, meaning when you create table, you have to also commit the transaction. The SQLite driver, SQLite I think has transactional DDL, but the SQLite driver turns it off. So basically, using engine begin is a good idea when you create your tables. So it creates the user table. So you can see SQLAlchemy did a few things to check to see if user already existed, doing SQLite's pragma command. And then you have the user table. And you have where we use the string data type. You see varchar came out. You can see our primary key. Here's a fancy table with more stuff. A datetime column, a precision numeric column. Use a string as the primary key if you want. Do whatever you want. Here's an enum. SQLite doesn't have enum built in, so when it does the create table, you see varchar1. It's varchar1. Actually, it should be char1. Maybe SQLite doesn't have char. And of course it does. It's a size 1 because the enum had 1 character elements in it. So that's a fancy table. When we have the metadata object, we've made 2 tables now. We can actually see those tables inside the metadata in a dictionary called tables. So when we look at the keys for tables, we see user and fancy, and we can actually pull up the metadata, the user table. We can look at the fancy table like this, and that's basically the same object as the fancy table we made. So it's inside of a dictionary. Another table to show some things off, and this will be kind of one of the tables we're using some of the examples, is the table to store email addresses for each person that has a user account. So this has something called a foreign key, and hoping people know what a foreign key is. A foreign key in a database is a constraint on a column or set of columns that means that every value in that column must exist somewhere else, typically as the primary key of a different table or of the same table. Primary key, a foreign key is usually referred to the primary key of another table. Some databases like Postgres allow you to refer to a unique constraint as well. But in the vast majority of cases, the foreign key is a constraint that makes sure a value in this user ID column will definitely be in the ID column of the user table. So we set this up, again, in a way that looks like DDL. Column user ID is a foreign key to user.id. We name it by its string name, and then when you create the address table, you can see at the bottom, foreign key, user ID, references user ID. To show a composite foreign key, a composite foreign key is a foreign key that has more than 1 column, and you use that when your database primary key has more than 1 column. It's called a composite primary key. you want to create that constraint as one constraint, not two separate constraints on each column. So a foreign key constraint on multiple columns is declared at the table level using the foreign key constraint object. And you can also use foreign key constraint for a single column key. It's just more convenient to use foreign key. These two tables are not going to be part of our examples, but just to show some more stuff, this is stories, has a primary key for each story, but then there's different versions, so the primary key is composite. I guess people kind of know this, composite primary keys. Hopefully, create table for that. You can see the foreign key at the bottom has the two columns in it, referencing the two columns. Check on the time. So for this section, we have to 9:55. Okay. Reflection. So that's DDL. That's how to create tables and run DDL. Reflection is the other direction. I'm going to try to get this done by 55. Okay. Let's make a brand new metadata object that's empty. Are there plans to make Alembic a built-in feature of SQLAlchemy? Well, no. Alembic is very linked to SQLAlchemy, but it's a separate package. So it is certainly very joined with it as far as how it does things, but it's always going to be separate because it's its own thing. And there's other ways to do migrations too. So yeah, it'll be separate. Metadata, we make a new metadata collection, is empty. We put a new table into it, but we don't give the table any columns. We just say it's empty. And then we say, hey, table, can you please auto-load the information about your columns and indexes from the database? So here we do engine.connect. We don't have to use a transaction. We don't have to say begin because this is just a read-only method. So this table object will, when it gets created, will load its columns from that connection. And then you can see a bunch of SQLite pragma stuff. It's a little redundant. The reflection logic is not well optimized yet for SQLite and some other databases. That's a long-term goal to make it more optimized. Anyway, the user table that we just reflected is a brand new object, and it pulled up all the information about its columns and primary key constraint and any other constraints it might have had from using database introspection. If we want to do more fine-grained inspection, we can use a, excuse me, that's breakfast, a function called SQLAlchemy inspect. You run inspect on the engine, and it'll actually handle connecting for you. It's a read-only operation. And inspector can give you things like the names of tables. It can give you the names of columns for a specific table. It can give you the list of foreign keys for a table. It's giving you the data in a raw kind of JSON-ish format. It's actually Python dictionary, so it's not string. And then also there's a feature that people like a lot, which is that you can get another blank metadata or a metadata that's already got tables in it and tell it to reflect every table that you don't already have. Get every table into the metadata all at once. You say metadata.reflect with a connection. And you see it ran a lot of queries. And you can see there's pragmas for all the different tables. That's because the first thing it did was it did select name from SQLite's master table. It got all the names. So 2 questions. The thing about someone asked about backgraphs. Backgraphs have to do with the ORM. So backgraph does not apply to what we're doing right now. It's only when you use the ORM that you might want to use a backgraph. And the answer is the backgraph is always an optional thing. You don't need to use backgraphs. And actually, if and when we get all the way to the ORM part of this tutorial, I'm actually not even going to use backgraph. I'm going to use a different keyword called backpopulates, which is a little more clear than backgraph. What is reflect used for? I think reflect is used for, well, first of all, the Alembic tool uses it because it will compare your model code to what's in the database, so it uses it like that. It can be used if you have an existing database, like if you have like a WordPress database or a PHP, whatever database, and you want to just play with that data and migrate it and move things around. It's very handy to just reflect all the tables and just work with them rather than having to rename all those tables. That's basically the use case I see for it. Caching metadata, I think people try that. I don't really like that use case. I think if your application is coded to a set of tables and that's the tables you're using, I would be using the metadata would be first and foremost in your database, in your application. That's the canonical place that your database metadata is represented. If you're doing something with a database that your DBA manages, then maybe you want to use reflection. Reflection is a little bit slow though, so yes, you can pick all the tables. Yeah, it's good for migration. Yeah, I'm not a big, I use reflection just for migration stuff and quick and dirty stuff. I don't use it for main application development, but some people do. SQLAlchemy is trying to be open-ended about what you want to do. So if you want to read the tables, you can do whatever you want with them. Once we reflected the whole database just now we have metadata. The table has all the tables that we just did inside of it. They're all there, and you can get them all back. So that's that. Yeah, so you can now use those tables to make SQL statements. So that is the end of the metadata part. So these are these first two sections are intentionally kind of quicker because when we get into the ORM stuff, it's going to be slower because there's going to be a lot more questions. There's a few more slides to do with metadata. Here are just some basic types: integer, string, Unicode, which is a string, but it's going to generate different DDL, and also it might have different handling inside of it for how bound parameters and result sets come back, particularly in Python 2. We have to do a lot of Unicode conversion stuff. Python 3, it's pretty much taken care of. Boolean is tough because databases don't all have Boolean. Will string go away for Python 3 is a question. No, because the string is varchar. See, this is where we're kind of honoring what the database does. So your database has a varchar type, and it might have an nvarchar type, and they're different. So if you honestly want to work with the varchars in Oracle, you'd want to use string and not Unicode. Or if you want to work with the varchars in SQL Server that has nvarchar, you'd want to use string. So the thing is, a string data type will take a Python Unicode, and it's fine. So the string Unicode thing is a little bit fungible. You should use the Unicode type if you definitely want to store Unicode and you want the nvarchar type for those databases that support it. Boolean is tricky because databases don't all have Boolean. So like you got to use tinyint or bit, int. There's some crap happening with Boolean. Date time returns Python date time objects, receives Python date time objects, also date and time separately. Floating point values, which are different from numeric. So it's the difference if you want to get a Python decimal object or a Python floating point. We now have JSON. Postgres, MySQL, and SQLite all have a JSON type now. So use JSON for that. Postgres also has JSON-B, which is like a binary JSON that's more efficient or something like that. Postgres has an array data type. You can also, this is a quick rundown of the create and drop methods. When you have a metadata object, you can say metadata create all. You can say table.create. You can say metadata drop all, table.drop. They all accept a database connection as their argument and an optional check first, which will either run the create drop unconditionally, which means it'll fail if that object is present or not present. Check first will run an introspection to see if a certain table exists or not as appropriate. You can also pass an engine to create all, create, drop all, and drop. However, I might be changing that for 2.0. It's better to extend a connection because that way you are defining the scope of this connection and the transaction, stuff like that. It's a bit up in the air if these methods will continue to accept an engine or if connection is required. That brings us to the core SQL Expression Language. And this is where the slides begin to get longer because there's a lot more to talk about. The core SQL Expression Language builds upon the table metadata in order to compose SQL statements in Python. So we will build Python objects that represent individual SQL strings that we'd send to the database. These objects are composed of other objects. They're using the compositional pattern that represents some unit of SQL, like a comparison, select statements, conjunctions, casts, all kinds of things. Anything you can imagine, we have some kind of version of it. Let me take the Zoom group chat away. we work with these objects in Python, which are, excuse me, sorry, that must have been terrible over the microphone, should then convert to strings when we execute them, as well as if we print them. Focus. And SQL expressions in both the core and ORM variants rely heavily on the method chaining programming pattern, which means you have an object and then you say object.method, and you keep getting a new object back. Or the same object, depending on what kind of method chaining. But method chaining means you're going to have object.function method. All right, so we have two sets of slides for these. And let's go to basic. And then after this basic one, we're going to have probably a 5-minute break. Excuse me, where we can hydrate a little bit. So let's again begin with the table object that we had before. Not quite the same, but close enough. And then we're going to create that table in our SQLite database, right? This should all be old hat now. So there's our user table. So now we have this user table, and as we saw earlier, it has this collection of column objects on this .c attribute. What can we do with .c, with usertable.c.username? We can make an expression. Usertable.c.username equals SpongeBob. And unlike Python, which if you say 1 equals 2, you get false, 1 equals 1, you get true. For some reason, when we did this user table thing, we got this whole new object called binary expression, which is unusual. And that's because Python has magic methods called EQ and not equals and GT, and you can actually make an object in Python that overrides these to do something new. And that's kind of SQLAlchemy's main thing, is that you make expressions using overloaded Python operators. And I got this from a tool years and years ago called SQLObject, which was first written by Ian Bicking, and SQLObject still exists today. And the idea of using the Python expressions, I ripped it off from Ian Bicking. So Ian Bicking gets credit for the double equal sign thing. When you have this expression, if you stringify it, you get SQL, which interestingly enough does not say SpongeBob. It has this bound parameter inside of it. That's weird. So keep in mind that when we have these little objects, you can call compile on them to get the full what we call compile object. It's a SQLAlchemy object called a compiled, and it has the parameters separate from the expression. So if you do the compile, there's also string. Yeah, there it is. So we have a question, and it says the DB is doing the expression, not Python. We haven't done anything with the DB yet. This is all happening in SQLAlchemy. So you basically have this this expression object. So let's say expr equals user table c username equals x. Expr is the binary. Expr has a left element. It has a right element. It has an operator. And then there's this thing called a compiler in SQLAlchemy that just takes that basically expression tree and does this thing called compile. And then we have this stir SQL compiler object, which is all Python. You know, it's got a whole bunch of state in it. And we're just in Python. We're just taking objects and converting them to strings. Basically taking, it's just like if you had a JSON object and you're going JSON.dumpString. Or back in the old days, we would say XML dump. No database yet, but when we make these strings, those strings are what we will send to the database. A more elaborate string statement that is using the Python bitwise OR operator to do things. Another one using explicit method functions and OR, like that. And you can see this makes a bigger expression that's happening. And comparison, it's just different things that can happen with columns. You can do comparison to none, and it says, oh, you use none, so let me do is null or is not null. you actually don't want to use the equal sign comparator or not equals in SQL to compare to none, because it will return the value none, because null, because in SQL, null is not a value. It means we don't know the value. Operators are also type sensitive. If you have an integer and you use the plus sign, you get the addition operation. If you have a string and use the plus sign, you get the concatenation operator, which for the default comparator is the twin pipe operator. There's also an in operator that does some complicated thing. In 1. You actually have the syntax in 1.3, but in 1.4, in operators are expanded. It's kind of hard to explain. You send a list of values to in, and they're stored, but they are expanded into bound parameters when you execute the statement. I think we'll see this later. It's probably a little hard to explain if this is new to you, if this is new to people. When I do an in, the parameters that are sent in a list are stored as a single bound parameter that will be expanded into individual parameters when we execute the statement. I'll show you that later. I think this slide probably skipped a little ahead. So don't worry too much about in. Just know that in is getting better in SQLAlchemy 1.4. Databases don't have an empty in. If you send an empty list to in, it'll give you an error. SQLAlchemy now implements this by using special select statements inside of an in that return an empty set. And that is this logic is available in 1.3, but in 1.4 it's automatic. This is kind of migration stuff for people who know about working with in on SQLAlchemy. We've had some bumpy history. Let me up this little thing. Okay. Also, if you have an expression, based on what kind of dialect you're using, meaning if you're connecting to MySQL or Postgres, there's a database dialect that's in use under the engine. So if we have this expression that is string concatenation, if I run that on Postgres, I'm actually not running on a database. I basically have created a dialect called the PostgreSQL dialect. So PostgreSQL dialect is, again, a Python object in SQLAlchemy that just knows about how to generate SQL for Postgres. This one generates the SQL with a certain bound parameter format and the pipe symbol. If I run the same exact expression on a MySQL dialect, MySQL maybe does now, but for a long time didn't have the twin pipe operator. It would use the concat function. So this is an example of how we can make an expression in Python that is database agnostic. This is a very small example of that. Because we want to work with some data and select it, I'm going to first insert some data. So this shows how to use a construct called the insert construct. Given our user table that represents the columns and the table name of this table, we can say .insert, which returns to us an object called .insert, and we say, hey, insert object, insert these two values. That gives us a statement object, kind of like when we made a text object before, and then we run insert statement into the connection execute inside of our transaction with engine.begin, and you get an insert statement. So we wrote some Python code that has all the nice autocomplete stuff or whatever you want to have in your IDE, and it looks pretty nice, and it created this SQL for us. And it actually did return a result, but the result is automatically closed. So you don't have to worry about the cursor being closed. And it created bound parameters and put SpongeBob and SpongeBob SquarePants full name into the table as our first row. And then, because we ran into the transaction, did a commit. Let me see what time I need to do for this SQL 1. Oh boy, we're behind. Okay, 10:20. We can also run multiple statements. So insert and also the update construct, which we'll see later. They normally generate their values and or set clause from the list of parameters. So here we have userTable.insert, and we didn't say .values. We just said, hey, execute this insert statement, and here are some parameters. SQLAlchemy for inserts and updates will automatically figure out the values and or set clause from the parameters you pass. That makes it convenient when you want to do multiple rows, send a list of dictionaries. You can just have the names in the dictionaries be named after the columns, and the insert will just work. So we have some rows being put in, and we have all of the 4 characters we're going to be using in the database. When you send a list of multiple dictionaries to engine connection.execute. The DB API has a method called execute many that allows the backend driver to optimize the invocation of multiple statements. The MySQL driver does a good job at this optimization. The PsychoPG2 driver by default does not do a good job of this optimization. However, SQLAlchemy includes flags, some options to enable those optimizations. And in SQLAlchemy 1.4, I will probably make them the default so that PsychoPG2 inserts should be way faster, because they really had a very bad performance issue for many years that they've provided workarounds for now. All right, so now that we have some rows, that's why I did insert first, so we have some data to select. There's another construct called select. And we can build up a select. The legacy version of select is passed a list of the tables and or columns we want to select from. And the list is kind of a legacy thing, which is because the legacy select also accepts keyword arguments of like the where clause and the order by clause. That's all going away. The select will only be used by just sending it the list of columns or tables you want to select. And then when you want to add the where clause and the order by and whatever, you have to do .where, .order by, .group by, etc. It's going to be method chaining only. Most people use select this way anyway, because I've changed all the tutorials years ago to only use this style. So here's a select statement. We create the statement with username and full name columns. We add a nice where clause where we put our expression, and the whole thing is built up. And then we can run it, and we will get the statement run, and you get the row back. And then also, and I'm actually wasting time here, but I don't know why I'm doing this, because this is not interesting. If I run it again, you can see that on the second run, it was actually cached. So that's the new caching in 1.4. That one little word took me 1.5 years to develop. Anyway, here's how to select all columns from a table. You pass just the table object altogether, and I can do that. I can get everything back, all the columns. In the rows, I can put a where clause that has an or in it and an order by. These are examples. Okay, are the methods chained? Okay, question, are the methods chained in the same order they would appear in a standard SQL expression? No, you can chain in, okay, so that's a thing to note here. Even though I'm doing these like a official SQL statement, you can do where and order by and group by and having in whatever order you want, and they will be amalgamated into the statement in the correct order. Where that is not the same thing as if you're using subqueries, you want to, if you're nesting queries, then obviously you have to do one query first, then nest it, then build it. But I can say select user table and do it all in the wrong order. Watch me get all the IDs wrong. Okay, print. Did I get it all right? There you go. So yeah, you can do the group. You can do whatever you want, and it knows where the where clause goes. It knows where the from clause goes. One thing to note that's happening here, and I don't even mention it because it's just so normal to me, is that we're not even telling it about the from clause. The from clause is usually automatically derived from the thing that we're selecting from, and the where clause, if we were selecting from one table and saying where something about another table, it would put both tables in the from clause. So it's like an implicitly generated from clause. It's, so it actually has some nice side effects that we'll show off in some subsequent slides. We want to be done in 4 minutes. Good. So we're in good shape. Okay. So if you can say multiple where clauses that'll be joined by and. So you can have where this and that. You can use the and function directly. You can mix and match. It should, usually do what you would expect. An update we've seen insert and select. An update looks a lot like the insert, but it has a where clause, so in that way has something that the select also has. So we're going to do update user table where the username is Patrick. We will set full name to be Patrick Star. So in this case, there's two different bound parameters for this update statement. One of them is derived from the where clause, and the other one is on the fly from the parameters that we passed as the set clause. So basically, the set clause comes normally from what we just sent. We also could say user table update values. Did I do that right? You can do that too. An update statement does not have a values clause in SQL, but we use the values method. That's also the same values method that insert uses. We might eventually add a dot set to make it more clear, but generally the set clause of the update comes from the dot values or comes from the parameters that you pass to execute. And then finally, I think it'll show a delete. Nope. First we're going to say update with some expressions. So values can also do expressions. We want to set the full name column of the table to be actually the concatenation of username and full name, which doesn't make much sense operationally, but just to show that you can put SQL expressions in the values clause. And there's actually also, I'm not going to show this here, you can actually update, some databases allow you to update the sub element of a JSON object as well, and we support that too. It's a pretty edgy case. And then a delete, again, looks like an update, except there's no values or set clause. So we want to delete Patrick, and then we run that, and that will run the delete statement. So that is the end of SQL part 1. And so we have any remaining questions? Otherwise, this is the 5 to 10 minute break where I'm going to first go to the bathroom, and then I'm going to probably go on Slack and chit chat.
Yeah, if anybody has any questions, definitely feel free to just unmute yourself and ask.
You're welcome. Let me see what's happening in Slack. So when I pull up Slack, now you guys will see my Slack, right?
Mm-hmm.
Okay. I don't use Slack much. So what is this little wiggly thing that everyone's doing?
The bird.
Is that a bird?
Yeah, I don't really know the origin, but I didn't know it until I started really using Slack. To be frank, I'm more of a Discord guy myself, but I guess it's just a meme and it looks funny, so
Yeah.
so folks use it.
Yep. I also did mention that I did make the source code to all this public on the GitHub link. I see someone asking for the link. Do people all have the link?
Mm-hmm. Yep, you should see that third message up from the bottom.
Up there.
I'll send it
Okay.
out
Yeah.
again.
You don't have to run the code. Like back when we used to do this tutorial in person in the real world, we would have people running it, and obviously it's not always easy for everyone to get it installed. So I'm going to take a quick break for about 2 minutes and come right back. So you'll just see my empty chair. Is that cool?
That works. I'll throw some music on. How about that?
Nice. Okay, right back.
Fine.
There's no good reason to call it over. Just a feeling in my bones, and I can't ignore it. Good on paper, you're going nowhere. See that look inside your eyes, and it's getting colder. I've been getting dizzy from all this back and forth. Tell me am I losing my head or losing my heart? 'Cause I don't know what's worse. I just know that I don't wanna be the one holding you down. I'll never belong here wearing a crown. I gave you everything, but I know better now. I gotta let go. I just wish I knew how. Wish I knew. Wish I knew. I just wish I knew how. Oh, 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 oh. Just wish I knew how. Gotta let go. Gotta let go. Help me let go. Just wish I knew how. Gotta let go. Gotta let go. Help me let go.
Oh, wow. Turn that up. What is the story?
Not much. I think we actually have some questions here in Slack.
All right. Do you want to do some questions? I mean, I'm pretty happy I made pretty good time. When I've done this talk in the past, I'll be at the end, be like, to get to the end. So I hope that we're not doing that. Because silly me, I put even more content this time. So I don't know.
Yeah, I think if you want to answer a few questions right now, this is definitely time to do it.
Yeah, people see me right now, right?
Yeah, then they should.
Great.
Yeah, I hope
This is
so.
my first exposure. Okay, exposure with SQL by hand.
So let me pull up Slack here.
Well, I see a question that's kind of for other people there, so that's refreshing. To have other
Yeah.
people.
Yeah.
So yeah. So what convert others? I don't know. You know, it's my winning smile. The SQLAlchemy 2.0 compatibility. Someone asked about that. Yeah. So it's SQLAlchemy 2.0 has a couple of hard incompatibilities, which is why the 1.4 version has a transitional mode. So 1.4 is backwards compatible, and then there will be a environment variable you can turn on where 1.4 will act kind of like, I don't know if people remember when Python 3 came out, there was a Python 3 warnings mode that would warn you in Python 2 about all the things you're doing that are not Python 3 compliant. This is simpler than that. It's not nearly as bad. So there's a mode in 1.4 where you'll be able to have all these warnings come out saying, okay, this won't be able to, you'll have to do it this way. So you'll be able to write your application. You'll be able to upgrade to 1.4. Then you'll be able to migrate, your application to be, 1.4 future compatible. And then the theory is, and we'll obviously be testing the crap out of this, is that you can then put 2.0. And so 2.0 is compatible with 1.4 if you've done 1.4 in the future mode. So there's an upgrade path that, I mean, we've had so many big hard upgrade paths. We had 0.1 to 0.2, 0.2 to 0.3. We changed the API a lot. So we've done this a lot. And this is the biggest one probably, but it's going to be fine.
Fingers crossed. Right?
Yeah. What's I need to look at the time? 10:27.
do
SQL
you-
part
yeah.
2 is really long. What was that?
Are you trying to get started like what, like 10:30?
Yeah.
Start back up. Okay. Yeah. I mean, if anybody has any other questions, again, feel free if you're in the Zoom or if you're using Slido or Slack or whatever you're using, definitely feel free to ask some questions. This would be the time to do it.
I have a question. I'm sorry. May I jump in here?
Please.
David Bear here. I just, with the expression language, do you have like left join and right join methods that you can use?
Yeah,
or-
so the next chapter is going to show joins. But funny story, we don't actually have right join. We have left join. So we have inner join and left outer join, and then we have full join. A right join is kind of a controversial black sheep of SQL because it's a left join in reverse. So almost all, but no right join is not. So with a right join, you need to just reverse the order of your tables.
Okay, thanks.
Cool. Good question.
I would never understand right when I see right join. That's too much for my brain. It's like no, sorry. Please just reverse it. There's probably some Oracle query planning crap that only works with right join, but I haven't heard about it yet.
Yeah, reading left to right makes more sense for most of us.
Yeah, there's enough. I mean, SQLAlchemy with the ORM, there's enough left, right, left stuff that I've spent years learning to be second nature. That right joins, I can't. It's my brain is full. All right.
Maybe it
So-
makes sense for those who read, right, like Arabic speakers. Maybe.
Maybe, yeah. Yeah.
Awesome. Well,
All right.
does anybody have any other questions real quick? One quick one, or if not, then we can get started.
If I may, this might take way too long, but I was migrating data from an Oracle database into Postgres. I had a results object of my Oracle data. And the only way I thought I could really make sure each one of those rows was committed was to iterate over the result object one by one, and then do a commit after each iteration. And it turns out it's really, really, really slow. Is there a way I can perform a commit on like a results object into another table without having to iterate over individual rows?
Yeah. So if you're transferring from Oracle to Postgres, so the data has to be in your Python app first. So yeah, you take the rows and they're tuples, but you can make them into dictionaries, and then you would pass them to connection or whatever you're using, execute. The Python database API can have a single insert statement with any number of argument sets passed to it at once. So an execute many style call, which I showed in one of the slides previously, you want to probably do batching, meaning if you have 20 million rows, you wouldn't want to have 20 million rows all in memory at once. So you'd want to maybe get chunks of 10,000 rows at a time. But you can send 10,000 rows or whatever at a time to a single connection.execute statement, and it'll be passed to the psycopg2 driver. As I mentioned before, psycopg2 is a little slow, but there's some flags that you can turn on in SQLAlchemy to use the faster insert style, which actually is going to convert the query internally to some other stuff. But yeah, when you iterate a result set, you would not want to commit after each row. You want to, even if you were running multiple insert statements per row, you still want to get the results and run the statements within a single transaction using engine.begin if you're using core directly.
Okay, thanks.
Cool. Another good question. That's awesome. Well, Mike, again, I mean, if you want to just take over and drive again.
All right. So am I in a screen share? Because it looks like it's different.
Yeah, you just got a screen share again. I
Share
stopped
screen
it.
again. Okay, good. Cool. So now you see my Slack. Okay, and then we go to here, and now you see that. Okay, so now we're going to go to SQL Advanced. Oh, this is not the long one. Okay. So now we're going to do joins and subqueries and common table expressions. So this is the first version of this tutorial that has common table expressions in it. If you saw the old one on YouTube, there were no CTEs. So again, we're going to start with the table like we had before. We're going to keep using the same table so it's familiar. And then for the second table, because we're going to be doing joins, there's the second table that we've seen with the foreign key. Actually, I put the columns in different order here. It doesn't matter. And then we're going to create those tables. So we have these two tables, user and address. Is the bandwidth okay? I'm noticing that my image is herky-jerky all of a sudden. You guys getting me okay? Thumbs up. Good. Okay, so user and address and the foreign key. And then we're going to put some data in. So this is now that we know how to do this bigger data. So this is the person that asked a question about insert execute many. If you have a lot of rows, you can convert them to dictionaries here and do connection execute and then send the list of rows. So we're going to put in first a bunch of rows in the user table, and then we're going to put some rows that refer back to those rows into the address table. Now SQLite by default does not actually enforce foreign key constraints. There's a pragma you need to turn on. But normally you want to put the rows that are dependent in second. You want to put the first rows that are primary first, and then so that those primary keys are present, then the next set of rows will be the ones that point back with the foreign keys. When we use the ORM, this detail is all taken care of for us. But anyway, we're using explicit user ID 1, 2, and 3, and then the second bunch of rows are going to set some email addresses for some of our users. So we run that and you get all the insert, and actually it's more succinct because you could see when it runs, you can see the statement is hit only once, and you can see the individual sets of rows are put in and the bound parameter format comes all out, it all gets done for us. And like before, a couple of slides back, whatever, we had a future engine. We're going to do that again. We're going to have another engine. Actually, no, I'm wrong. I'm reading my slide wrong. We're going to have a future select. So the two things in 1.4 right now that are part of the quote-unquote future package, there's a new create engine that gives you a slightly different engine, and there's a new select that gives you a slightly different select. So we're going to compare and contrast the current select object, which everyone who uses SQLAlchemy probably knows, to the new one that we will name here as future select. So from SQLAlchemy import select, from SQLAlchemy.future import select as future select. And then we're going to just connect to the engine. We're not going to use the context manager because we're going to do a lot of queries, so we're not going to have the indentation of with the context manager. It doesn't work too well. In the slide runner here. So the first thing that we can do with the two tables is join them. So this is where we talked about the inner join. This is an inner join. And I could also say user table outer join, address table. And if I print that, you'll get left outer join. And already people might notice something is that there's an on clause of this join. The one up above, up here, I said join object equals user table, join to the address table, and join on user table.id CID equals address table.c user ID. Okay, and then you print that and you get this join. The second one, I didn't put the on clause, and that's because user table and address table have a foreign key between them. SQLAlchemy already knows how to join these two tables by default. There are other ways to join the two tables, and if you wanted to join on like the name matching the email or something like that, you could name that explicitly. But if you don't give it an on clause and the two tables have a non-ambiguous foreign key relationship between them, meaning there's not multiple foreign keys, it will generate the on clause for you. And people that use SQLAlchemy pretty much know to do this. And then the next example shows what I just told you. So using the core, using our classic 1.x version of select, if we want to select from that join, Recall earlier I was saying that the from object is implicit. If we want to select from the join, we have to tell it that. So we say, hey, select a column from the user table, select a column from the address table, but don't select from those two tables separately. Select from the join of them that we just created. So if we run that, we will see a statement that is select username, email address from user join address. There's another kind of statement where you could have done what's called an implicit join. If I were to say, let's do this, statement equals select. Then we move the Zoom group chat over so I can type. Address. So what I just did there is called an implicit join, meaning I'm selecting from the user and address tables, but there's no join keyword. It just says from user, comma, address, and then in the where clause I join them together. That's called an implicit join. The actual SQL join keyword is way more flexible because it includes the ability to do what's called an outer join, which everyone that here that knows SQL would know means it's going to select rows in the primary, the left table, that also do not have a corresponding row in the right table if you use an outer join. So an implicit join using the where clause is basically an inner join. So that's what we're saying. So you can do either way. SQLAlchemy is very explicit. We're not trying to like guess how you want to do this. If you say you want join, you get join. If you say you want where one column is the other column, you get the where clause. It's very explicit. It's very WYSIWYG about that. Now, the future select includes a feature that users of the SQLAlchemy ORM would know very well, which is that in the ORM, there's an object called query, which we'll see later, has a method called join. We now, in the future version of select, have a method called join on the select object. Now, the reason join is part of the future version is because there actually is a join method on the current SQLAlchemy select construct, but it does something very useless, and nobody uses it. So in 1.4, at the moment, I'm actually having the default join just raise an exception because nobody uses it, and when you do use it, it ends up making a query that's very broken. So for the moment, the new join is only on the future select. I might move it. I'm not really sure how to do this because the thing is .join does behave differently in the future version of select than in the classic version. It's just that the old API is very broken and useless. So when I use the future select and I want to join between two tables, I have the option. I can still use the other form. I can say select from join. I can also say select from user table and address table, and I say .join to address table, which means join from the first table to the other table. And this is how the ORM query works as well. There's many ways to make this explicit. So that will do the same statement. It'll be like username, address, email address, user join address. And part of the reason this is doing this is because, as I mentioned before, and I hope if we get all the way to the end, if we get all the way to the end of the slides, you'll see this. This future select object can also select ORM objects too, and actually acts as a complete replacement for the ORM query. So it had to have a join method because the .join method in the ORM is pretty important. But for people who don't know this, I shouldn't be talking yet because I haven't shown you yet. There's a join method on this future select, and it is more automatic. What's next? When we work in SQL with tables and we want to select from the same table multiple times, there's this thing called an alias, which is like select from table as some name or as some other name. SQLAlchemy has a concept called the alias, which will generate a quote-unquote anonymous name for you, or you can give it a name. In this example, we're selecting from the user table, and then we're going to join twice to the address table as an alias. So we want to join to the address table as a certain alias and look for a certain email address. And then we want to join to it again as a different alias. So to do that, we give it the .alias method, and then we assign the result of alias to a new object. So this is something about SQLAlchemy that is, again, to me, it's hard for me to even notice it anymore, is that when you're writing a statement and you refer to different tables and things to select from, they render, they're tracked in the statement based on their Python identity. Meaning anytime you refer to the address alias 1 object in your statement, that will render appropriately for that clause in the SQL. And anytime you refer to the address table plainly, it'll refer to that. So you can have any number of Python objects that represent tables or aliases of tables or subqueries. And as you mix and match them in this object we're creating, which is a select object, basically, the expression system, when it compiles it, knows that the different Python identities refer to the different elements of the select. So, and this is not something that you really get in SQL, because in SQL you're writing a string and you say select star from address as foo, where foo.x equals y. You know, and here it's not about knowing the string name foo, it's about knowing the object address alias 1. So you don't have to worry about the strings, and that's why when you make an alias, you don't need to give it a name. SQLAlchemy will give it a name for you that it'll just use and it'll just work. So when we run this statement, we will see, and then let me move the group chat thing up here, right? So you guys can see the SQL at the bottom of my screen. It has the select and it has user join to address as address 1, join to address as address 2, and then it says where address 1 is something and where address 2 is something. So basically we looked for the SpongeBob row in the database for a row that has 2 email addresses separately with these certain email addresses, and we got back that one row for SpongeBob. Time for this is going to be till 11. Okay. A subquery kind of works similarly. It's kind of like taking a table and an alias and the select object together. So basically, if you take a select object and you say .alias on it, that will actually make a subquery, meaning the actual object you're dealing with is another table-like object. And this is kind of the thing about SQL, is that SQL is composable from what they call in relational algebra, they call them relations. A relation is normally what we call a table, but a relation can also be a subquery or something else. Anything that returns rows is a relation, not to be confused with a SQLAlchemy ORM relationship. And so basically the way table objects have a .c on them, which gives you the names for all the columns, and then you can use that table.c in a SQL, a select statement. If you take any select statement, you can say .alias, or in 1.4, .subquery, which is more descriptive. And you have this new object that has a .c on it. So select subquery here is going to have a .c that has both username and email address columns on it. These are not the same column objects as the user table username. It's the column object that comes from the subquery. So when I run that, if I select from my subquery as if it were a table, I get select anon one, which is the name of the subquery, it's anonymous, from the subquery. So that's different from if I said select, address table C, email address. So if I select from that column versus if I select from so what I'm trying to illustrate here is that there's an address table that has a .c email address, and there's a subquery that has .c email address. And when you select from one or the other, you get a very different query. So that's kind of a bit of a conceptual leap for people who haven't seen that before. Once we have a subquery, then we can really go nuts. We really have the power of SQL here. We can make a query that will select how many addresses each distinct user ID has using group by and the count function. When you want to use SQL functions in SQLAlchemy, these are usually aggregate functions, but there's all kinds of functions, especially if you're in Postgres. Postgres has crazy amounts of functions. All of the functions are implicitly generated from this namespace called func. So I can say func XYZ and get the XYZ function. Someone the other day asked about like bit shift or something like that. I get function bit shift like that. I can say bit shift. I don't know what bit shift does. This is a fake function. I'm just making it up. I can say do that, select from bit shift, and you get whatever that means. Means nothing. So up here we have an address select that is going to select the user ID from the address table and the count of the distinct IDs, and it's going to group by user address ID. And then that's a select statement. We're going to tell SQLAlchemy to turn this thing into a subquery, meaning give it a .c attribute, give it a namespace. One change for people who know this stuff already, the newcomers won't understand this. In SQLAlchemy 1.3 and before, the select object itself has a .c on it. That is deprecated because it doesn't actually make sense in SQL. I mean, it's actually possible syntax in some databases, but in general, most databases require that a subquery have a name and parentheses around it. So if you want the .c attribute from a select statement, you need to make an alias of it first, or a subquery. That's a kind of a big design change in SQLAlchemy 1.4, and you'll see that in the migration notes. It shouldn't affect people because people have already been using subquery .alias anyway, because databases like Postgres will not accept the query if you don't do that. So we've just made it more strict in 1.4. So when we're going to make another query, we're going to take that address subquery we just created that has the count. It's going to select all the user IDs and how many addresses they have, and then we're going to join that to the user table. And once again, because user table and address table have a foreign key between them, SQLAlchemy even knows how to join to the subquery. Even though the subquery doesn't actually have a foreign key in it, SQLAlchemy has this rather elaborate system how it knows that the subquery is derived from a table that has a foreign key. And SQLAlchemy knows how to generate the derived on clause between the user table and the address subquery so that we can get the name of each username from the user table and how many email addresses they have. Does anybody have questions about that? Because this took kind of a jump conceptually. And then a lot of people love this thing called a common table expression, or CTE for short, which really at its basic level is a lot like a subquery. It supports some other tricks like a recursive subquery, which is also something that SQLAlchemy supports. I find them hard to understand, but we support them. If you have a subquery, you can also, instead of using subquery, you can take the address select. Notice that address select here is the select statement. It's not the subquery. So we can take that address select and do address select.cte. And this creates, instead of creating an alias subquery object for us, it creates a CTE object. We can then take this CTE object and use it in exactly the same way as we did before. We want to select the username and then the count. And instead of getting a subquery in the from clause, we get a common table expression, which means that the SQL statement has a with clause at the top, and it names one or more select statements, or actually they could be inserts and updates in Postgres, but normally select statements that are then addressed in the query. So from SQLAlchemy's point of view, this is kind of a cultural thing. A lot of people, once CTEs became well known, people were like, where are the CTEs? I want to use CTE. And I'm like, SQLAlchemy doesn't care. It's the same as a subquery. Just use a subquery. Like from a syntactical point of view in Python, it's exactly the same. You don't do anything different, whether it's a subquery or it's a CTE. The reason people want to use CTEs is because they affect the efficiency of the query, and they change the query plan, and they don't cause Cartesian products. So there are reasons that I came to appreciate. So now, if you want your subquery to be a CTE instead, you do .cte, and then you refer to that object in the same way as though it was subquery, and the SQL will all work out for you. I'm just watching that Zoom chat. No one's asking me questions. Okay. Another kind of subquery is a scalar subquery, or a correlated, which can also usually be a correlated subquery. It doesn't have to be correlated. The subqueries we've been showing so far, I might refer to as a from clause subquery, meaning it's a subquery that returns one or more columns and 0 or more rows. You can take those queries and treat them like tables and put them in the from clause and have it join. There's another kind of subquery that is a scalar subquery that you can use in the where clause of a SQL select statement or in the columns clause. And the requirements of SQL on most databases, with some couple of exceptions that I know about but not generally available, a scalar subquery needs to return exactly 1 row and 1 column. If your scalar subquery does not return 1 row and 1 column, you'll get an error message at runtime when you run the query. The database will give you that error. SQLAlchemy is not going to police your scalar subquery. I probably didn't mention that one of the things about SQLAlchemy is that we do not try to reinvent what the database does. If the database is going to parse your SQL and tell you if it's good or not, we let the database do that as much as possible. We don't try to prejudge your SQL, with some exceptions. But if you send a SQL that's doing something or another, we try to let the database tell you, we let the database do as much of the work as possible. So anyway, when you do a scalar subquery, if you select it from an aggregate function, that's a good way to make sure you have only 1 row, because an aggregate function is going to take all the rows that match and it's going to roll them up into an aggregate, into 1 value. So say here we do a query that's going to select the count of addresses, and it's going to also do this where clause against the user table, which is a little strange because we really need the user table here. When we print this query by itself, it says, okay, select the count of addresses from the address table, and then also select from the user table where user ID equals the address user ID. Now that's kind of a pointless query because the address user ID column is a foreign key to user ID and it'll always be there. It's not nullable. So this seems weird. We're going to take this scalar subquery, which we've denoted by calling this method called asScalar. Again, in Python, in SQLAlchemy 1.4, you can use the scalar subquery. There's a question that just came out, which is a good one, which is why is the table user quoted? Now, that is because in SQL, when you use a reserved SQL word as the name of a column or a table, it has to be quoted. So when we print these statements, SQLAlchemy is using a default compiler that is agnostic of all the databases, and it has a list of words that are reserved words. Like if I had a table called select, it would quote it. So when I print the statement, the name of this table is user, and the default compiler, for whatever reason, is treating the word user as a reserved word, so it's quoting it. But the funny thing is, when we run the statement on the SQLite database, when we run on the connection, SQLite does not have user as a reserved word, and that dialect actually does not quote it. So you'll notice a difference, good observation, that when I'm stringifying these queries, it's quoting user, the word user, as a table name or column name. But when it runs on SQLite, it's actually not quoting it. If you were to run this on Postgres, I think it probably would have to quote it, because I think user is a reserved word on Postgres as well, because it's part of the create user statement that most databases support, but not SQLite. That's why user is quoted. Anyway, what we're showing here is this is a query that's by itself. It's not really a subquery yet, even though we've said it's one. But when we stick it inside of another query, we say, okay, select for me the username from the user table, and then also select for me this correlated subquery address core. SQLAlchemy will auto-correlate the user table. So if you notice, there's 2 different select statements being printed here. When you look at select count from address, the first query has from address comma user in it. The second one just has from address, and there's no comma user, but it still has the where clause of user, and that is because this is a correlated subquery. So basically, when you take a scalar subquery and embed it in the columns clause or the where clause of another select, the autocorrelation will look for that any of those tables in the immediate enclosing select. If you are trying to correlate to an ancestor select, you have to do some special methods. There's a .correlate method where you can explicitly tell it what to correlate to and what not to correlate to. But the default behavior is that if you put your scalar subquery inside of a select, it will autocorrelate to the immediate enclosing group, which basically means it will omit that table from the from clause. And that is the end of the SQL Advanced tutorial part, and then we get to the ORM. So the timing is right on, and I don't feel like I'm talking too fast either. Am I not? I'm talking at a fairly relaxed clip, even though I'll probably have bronchitis from talking for 3 hours. That always happens to me. Anything we want to do before we get into the lightning round of the ORM? I'm just watching at that Zoom. Okay. Level 4, object relational mapping, and this is where everyone will have all of their questions. We're now at the highest level of SQLAlchemy. Okay, and we have a lot of slides, and I have to move this little thing over so that you can see my slides. Object relational mapping, ORM for short, is the process of associating object-oriented classes. We call them domain objects with database tables. Get the focus. Oh, let me go back. We refer to the set of object-oriented classes as a domain model. The most basic task of an ORM, any ORM, the very first thing it needs to do is to be able to translate between a domain object and a table row. And the thing I want to note about ORMs is that I feel that you have to be using object-oriented classes. When people talk about ORMs that are just trading up dictionaries, that's not an ORM. That's just dictionaries and namespaces. I come from the old school Java OOP Gang of Four, culture, where an object meant you had an object. Damn it! So by domain object, I mean you're using in Python the class statement, and you have class user, class whatever, and it has methods and attributes on it, and those attributes are going to be persisted in a row of the database, and then you can retrieve them back. Some ORMs can represent arbitrary rows. So in not just having your row, your database object, your domain object load from a table row, can load from a select statement. And SQLAlchemy and a lot of other ROMs do that too. And then this is a quick diagram that you could just look at in the GitHub. This is kind of a diagram of how to represent many-to-one and one-to-many using foreign key association. So on the right side is what a database would have, where you have rows associated to a parent row via foreign key reference. On the object-oriented side, this becomes a bidirectional relationship, whether you mean it or not. Your parent object has a one-to-many relationship to those child objects, and the child objects have a many-to-one back to the parent. And that's kind of the whole ball game right there. So I'm assuming people I hope people get this chart, because when you deal with the ORM, this is where it all happens, is this thing about relationships between tables and loading them and storing them and updating them and everything else. Other things ORMs do, provide a means of querying the database in terms of the domain model structure. And that really, so that bullet point is really the first part where it's like writing the SQL. I'm sure everyone has seen, or maybe not, I don't need an ORM, I want to write my own SQL. Well, great, that one bullet is the part that's the writing the SQL part. Everything else we just did is not necessarily about writing the SQL. There's a lot of other things going on that are outside of writing your own SQL statements. Some ORMs can represent class inheritance using a variety of schemes. SQLAlchemy supports 3 of these right now. ORMs can do sharding if you want your data to be separated across different kinds. If you want to have vertical partitioning, meaning different tables are in different databases, or horizontal partitioning, meaning different groups of rows are in different database backends for scalability. ORMs can sometimes transparently handle that. Concurrency patterns, row versioning patterns, ways to check that your row is the current row and you're not looking at a stale row. Data validation, coercion, all kinds of fancy object-oriented stuff integrated with the database. The 2 terms we hear a lot with ORMs are active record and data mapper. I actually had to look in Fowler's book just to make sure I'm getting these 2 terms right, because I've found them to be a little ambiguous. Active record means that when you have an object that represents a row in the database, that object is responsible for managing its own persistence and loading. So user record dot save, user record dot fetch myself. Every object is basically on its own and represents a database row all by itself, and there's no coordination between multiple rows, multiple objects. Data mapper style ORM is different. You have objects, and then there's some kind of central coordinational system that is making sure everything matches up correctly. SQLAlchemy does this using a pattern called a unit of work. There's also different configurational patterns. Basically, every ORM uses an all-at-once style where you have classes, and then the classes you name a bunch of attributes, and the attributes become database columns. SQLAlchemy also supports a classical mapping style, which is what we had in the original versions, where the table is separate, and you say, here's my class, and over here is my table, the table metadata that we see, and then I'm going to map them together. You can still do that in SQLAlchemy, although there's really not much reason to. So SQLAlchemy ORM is a data mapper. Modern versions use declarative configuration. The ORM builds upon SQLAlchemy core. The SQL Expression Language presents a schema-centric, presents a domain model-centric view of data. Key ORM patterns. Unit of work. Objects are maintained by a system that tracks changes over the course of a transaction and flushes changes periodically. The identity map. Multiple objects that are of the same primary key identity in the same table will be the same object, so that different parts of your application that modify that object within the transaction will all be modifying the same object, so that changes are tracked correctly. Lazy loading. Some attributes of an object may emit additional SQL queries when they're accessed. Eager loading. Attributes are loaded immediately. Related tables may be loaded using joins, so the primary select statement or additional queries can be emitted. And then we go to the ORM walkthrough. I'm going to take a 2-minute bathroom break. Okay, Josh?
You got it. I want to take this time to remind everybody that if you also have to go to the bathroom or get up and stretch, now is a great time to do that. Sitting down for a long time is not very good for you. So make sure that you're periodically taking time to grab some water, grab some food, stretch, and do all that good stuff.
All right. I'm back. ORM basic. when we do object relational mapping, we start with this object called a declarative base. The declarative base is basically a class that we're going to subclass. So when we subclass declarative base, it's going to have a table metadata collection that will track tables for us, and it will also keep track of all the columns, all the classes that we create. So the first class that we make here is the user class, which is going to represent the user table that we've been looking at all this time. We give it the name of the table, and we give it the columns. You'll note that we don't have to name the columns inside the column itself. We can just assign the attribute name, username equals column string, and the declarative system will assign the names to the columns for us automatically. The Reaper here, the Reaper method, dunder Reaper, is so we can see objects coming back in our examples. You don't need to put a Reaper. It's optional. Make user. User now has a table object stuck onto it as _table. And that's the same kind of table object that we were using in the SQL expression tutorial and the metadata. So that gets created for you from the declarative system. There's also an object that you don't need to really worry about called the mapper. And that's the mapper object that's actually doing the mapping. It's actually mediating the user class and the attributes in the class with the table. And as the ORM does things, it's constantly asking the mapper for information about how to map this class and how to query from it. That mapper is also an object that I showed over here in flavors of ORM. This is what SQLAlchemy classical mapping looks like, which is you have a class separate, and then you have this mapper object. The declarative system here does that for you, and it has shown to be probably the superior way to do things. So when you use declarative, you get a default constructor. That's your double under init method. You can see here, we're going to make a new user object, again, with SpongeBob SquarePants. So this is kind of like when we would have a row as a dictionary that we would insert using core to insert. But instead, when we want to represent a new row, we create an object. Now, creating this object did not actually do anything to the database. Nothing has happened to the database at all. We basically have this Python object sitting here. It's got a Python dictionary inside of it. It's got this little magic object called instance state that you don't need to worry about. You can actually look at that using inspect if you want to, but it's not needed for basic use. And when we created the SpongeBob, notice that the table has 3 columns. It has ID, username, and full name. We didn't give it a .id. However, when we access .id, we get something back. It's actually none. SpongeBob ID is none. Now, because we got none, that's basically a default value for a column that you didn't, for an attribute that you didn't give a value for. When we do .id, years ago, that would actually modify the state of the object, which was an implementation detail, and now it does not do that. That's since SQLAlchemy 1.0, about 4 or 5 years ago. Even though it says SpongeBob.id is none, there's no ID in the state. It's just strictly a default that's given you each time you call upon it. And that might also reveal to some people that these attributes are kind of magical. They're not just regular Python attributes. They're actually what I call instrumented by SQLAlchemy using a technique in Python called a descriptor. A Python descriptor is, if anyone's ever used the property decorator, the property decorator in Python is what's known as a descriptor. It's how you can give an attribute to a class, and then when you have instances of that class, you access .foo, .bar, but it's actually calling a method on the class, on the object with a self that will give you a value, and you can also do setters and deleters. So that's what SQLAlchemy is doing with this class. So when we made this SpongeBob object, all of the attributes that are mapped to a column are implemented using Python descriptors. Now we have that user object. We can take the metadata for the tables, the collection that's stuck onto the base, and we can basically use that metadata as it is to create tables. So we get the user table. That's the one we're working with so far. And then here's the new ORM thing. Remember I said that a data mapper ORM is going to have a mediation layer, a coordination layer between the individual objects that represent table rows. There's going to be this coordination layer that can have any number of these objects, and they will make sure they all get, modified, updated, managed, loaded, whatever, correctly. And we talked about there's going to be these two patterns called the unit of work and the identity map. The place that all happens is this object called the session. The session also, in most cases, it has options for this, but in most cases, you give it a single engine object, which the session will use as a source of connectivity. So whereas in all the other previous slides, we had engine.begin, engine.connect. Once using the ORM, the session now will do the job of the engine.connect, engine.begin for us. We no longer deal with the engine or connection directly in the vast majority of cases. There are cases where you can deal with them, but normally the session is now taking over the job of starting transactions, committing transactions, emitting SQL, interpreting results for you. So the session has a queue of new objects, meaning objects that it should insert into the database. You access this queue, you modify the queue using the .add method. So we have this object SpongeBob, and we just did a session add. Nothing happened to the database yet. We haven't even connected to the database yet. Well, we did to create the tables, but we haven't. The session hasn't even tried to use that engine yet, because nothing has told it needs to talk to the database yet. So when we put the object into the .add method, it gets part of a collection called the .new collection, which really should be named .pending, and maybe I'll make that name change. We call this object a pending object, and the pending is a specific name of a state in SQLAlchemy of objects that will be inserted, but have not yet been inserted. They will be inserted when they need to be, which is strange because we told it to put SpongeBob in the database. But the reason it didn't actually need to insert it yet is because we're always working within a transaction. And we're actually, the session won't really do, the session will not consider its work done until we call the .commit method on session. So if we were to say session.commit, it would be like, oh, let me get all my pending work out the door and then commit the transaction. And in this case, it would even be starting the transaction because we haven't even started. So basically, SQLAlchemy has this pattern, which is called like late evaluation, basically. You notice when we did create engine, we made an engine. It didn't actually connect to the database when we made the engine. It didn't do it until we actually said engine.connect. Then it connected. The session's the same way. It's implicitly in a transaction, but nothing happened yet. We didn't do anything yet. So it didn't do any begin. It didn't even try to talk to the engine yet. We added an object, but we didn't commit it. So I don't need to do anything yet. I'm going to only do something when you need to do something that is a database operation. Let's do a database operation. And we'll have a sneak peek here at what a query in the ORM currently looks like. And again, this is a part that is going to be changing for SQLAlchemy 2.0. But for now, everyone that's used the ORM knows this, is that we don't work with the select object directly in the ORM yet. We work with this thing called a query, which is a whole lot like a select, but a little bit different, which is kind of annoying, which is why I unify them. But in any case, for now, we're going to use traditional SQLAlchemy ORM methods, which is this query object. So we say to the session, hey, session, we want a query for user objects. And the session's like, oh, really? And we want to filter them on the ones where the username is the name SpongeBob. And it's like, oh, really? That's very interesting. Nothing happened yet. When we say dot first, this is what happens. The session's like, oh, you actually want a row. Oh, okay. Well, I don't have a database yet. Okay. Oh, this is engine. Let me create a transaction. Oh, let me connect. Great. Connect to the engine. Start the transaction. Okay, I've got some rows pending. Okay, let me push out those rows. Okay, there go the rows. There go the rows. Okay, great. Now we can do a query. Select star from user where username is SpongeBob. Boom. Here's your row. How'd I do? Okay, so that's what's going to happen. And I did not rehearse that either. So everything happened all at once because it is late evaluating. It's like, oh, you actually want a row. Well, let me push what I have so far into the database into a new transaction. And then let me select it for you and let me give it back to you. What has not happened yet is the data has not been committed. If you were to start SQLite up on another terminal, and if this were a file-based database, which it isn't, but if it were, SQLite would actually lock. It would lock you out. It would be like this database. Well, it probably gives you read-only. It depends on what you're doing. But the database is locked right now because it's basically open in a transaction. And so right now we're working with rows that we just inserted, and we can select them back because we're in our own transaction based on the transaction scoping, the isolation rules in effect. If we were on like MySQL or Postgres, other transactions might not be able to see what we're doing. I mean, unless they were serializable, they would see this. But you know, a transaction isolation means that you can't necessarily see what other transactions are doing yet. Actually, no, they wouldn't see it because it's a dirty read. So, duh. Okay. Okay. So we just begun a transaction, put a row in, and then selected it back, and there's a row. And we notice we got back a user object that looks like the one that we had. So we had sponge Bob is this user object, and then we just assigned our query result to also sponge Bob. Two different Python variables. And I'll show you something about that in a minute. The SpongeBob object that had none for its ID before all of a sudden has the number 1 for its ID. That's the auto-incremented primary key that I talked about earlier. SQLite has auto-increment for primary key integer columns. And those two objects, the SpongeBob and also SpongeBob, are actually the same object. They're the same. You know, the ID of SpongeBob is the same ID as also SpongeBob. And that's because when the session ran our query, it got the rows back. It looked at the primary key represented by each row and said, oh, I already saw that primary key. I already have an object locally assigned to this variable SpongeBob that is that same object. Let me return that instead of making a new object. Instead of making a copy, let me return the one that's already there so that any changes are all coordinated on the same object. That's known as the identity map and is basically yet another dictionary with keys that are the primary key identity of the object, which you notice includes the type of object, because a primary key value of 1 is nice, but that doesn't tell you which table you're stored in. So it's user ID of 1. And the values are the object values for those primary keys. So that's called the identity map pattern. It's in the Martin Fowler's Patterns of Enterprise Architecture book, which I highly recommend. And then also what's been happening is whenever you see the session inserting rows or updating rows or deleting them, that occurs under a process known as the unit of work, which means that the session is tracking everything happening. It's tracking all of the objects that are pending. So here we're going to add more objects. Like this is just like session.add, except we're going to add a list of objects. And then we're going to even modify an attribute on our existing SpongeBob. So what we have here are two objects that are now pending and another object that's in the quote unquote dirty state. Earlier, SpongeBob was known as a pending object. Once the insert happens and the session is put it in the session, it's now known as a persistent object. Persistent means it's persisted in the current transaction, not necessarily the whole database, but it's in the current transaction on the database side. Meaning if we were to commit the transaction, it would become permanent. But then when you have a persistent object and you modify any of the instrumented columns on it, it becomes dirty. So we have two pending and one dirty. We can look in session. Hey session, what objects are dirty? Oh, look, user has a dirty attribute on it. And what's pending? Okay, two objects are pending. So basically the next time this session goes to put data in a database, which is a process known as a flush, there's actually a method called session.flush that we could type if we wanted to, but we don't need to. It's automatic. It would insert these two rows, these two objects, and then it would update the other one. And we will see that Well, in this case, we're just going to commit. Let's commit the transaction. So what commit will do is it will also do a flush of whatever's remaining, and then it will commit the transaction. So we run that, and we have our new SpongeBob Jones full name, and we have 2 more rows inserted, and then the transaction is committed. And now we're in yet another state, which is called expired state. And then this is all configurable. The fact that the session flushed automatically is configurable, and what the session does when you commit a transaction or roll it back by default, which you can and sometimes will want to change, and there's a question I'll have to look in there in a second, is it will automatically expire the state of everything that it has, meaning all of the columns that are persisted will be erased. All of the collections that it will have when we show collections later will be erased. And when you access them, they will then do what's called a lazy load to reload that information in a new transaction. And what's happening here is SQLAlchemy is trying to make sure that when you look at an object that represents a database row, that database row is always part of a transaction. If there is no transaction in play, you should not be looking at the database row, which might be a little counterintuitive, but it's a default behavior. If you have like a web application where you want to load a bunch of data and then close the transaction and display it, you would turn this flag off. But to get the best, most correct behavior between multiple transactions at the same time, basically when we commit the transaction and then we're going to look at SpongeBob full name again, any number of 1,000,000 transactions could have changed that value by now. The row could have been erased. It's concurrent transactions because in database transactions, they're isolated from each other. But once you're outside of a transaction and you start a new transaction, your data could have changed. So the default behavior is the most quote unquote correct behavior, but it's also a little less performant. So when I say SpongeBob.full name, and then I'll look at the question in my window here, there's 2 questions. It's going to actually start a new transaction, refresh the SpongeBob, and show us the full name. And that way, if SpongeBob were deleted, it would say, oh, it's been deleted, sorry. Or if someone else, some other transaction modified it, it would change it. So now let's see. Let me move my Zoom window over. How high is the coverage of functionality of SQLAlchemy? Like, you mean code? So someone asked, Alchemy looks often in the shown samples pretty much like SQL. How all DB's dialects. So I guess this means how well is the code coverage, like how well is the Oracle dialect tested? It's certainly the source code is 100% covered, and there's probably several hundred, probably almost 1,000 tests that run against the Oracle dialect that are testing both Oracle specific features as well as agnostic SQL features that we want to work on Oracle. So the built-in dialects in SQLAlchemy, with the exception of 2 of them, the SQLite, MySQL, SQL Server, Postgres, Oracle dialects are super well crazy tested. And when we run a CI job, there's 200,000 tests that are run because the same 10,000 tests are run over and over for different database backends, different drivers. They're very, very highly covered. Someone then asked, so that all the new objects modified are committed as a transaction. Yes, so when you work with the session, there's legacy versions of it that don't do this, but they are deprecated and are going away in 2.0. The session, when you use it as per current instructions documentation, you're always in a transaction. So when it flushes rows, it'll flush maybe this row, it'll flush these rows. You're always in the transaction. So whether it flushes everything at once or flushes a little bit here and a little bit there, as long as you didn't say .commit or .rollback, everything is pending in the transaction on the database side. So basically, yes, things are always committed as a transaction. Unless you're using a mode of the session called auto commit, which is deprecated, it won't be there in 2.0. It does everything as a transaction. If you're using the deprecated auto commit mode, it still does each flush in a transaction. It's just that it won't do multiple flushes in the same transaction, which is I used to think that was okay, but I don't think it's okay anymore. So yes, it's pretty hard to not be transactional with the ORM session. It's pretty much hitting you over the head with transactions from the get-go. So that was an expire. So when the transaction's over, by default, and you can change it, and you might want to change it for some purposes, it expires everything so that when you access everything else, it will refresh itself. Next, we're going to do some rolling back of data. Okay. I'm way behind. So let me move faster. Haha. Rolling back of changes. Let's make some changes that we're going to roll back. Let's change SpongeBob username to some terrible name, and then let's make another user object that will be pending that we're not actually going to want. Let's then run a query for those new rows. So the session will be like, okay, let me flush them first, and then let me query. So it does the flush. You see the update and the insert occur, and then a select occurs, and you get the rows back, but they're not committed. They're not in the database physically yet. They're only in the transaction in a non-permanent state. So we don't want them. We do a rollback. So now what's happened is the transaction has been rolled back. The session has now, again, done the auto expiration. Everything that was loaded has been unloaded. Any changes to SpongeBob have been erased. Any pending objects are also removed because we assume they were either inserted or they were not. So now when we do SpongeBob.username like we did before, it begins again, but it has the old name because we did a rollback. And this is an example of how auto expiration is kind of a handy thing as long as it's doing what you need it to do. And then also the fake user object that we didn't want has been evicted from the session. The session calls this expunging, but it really should be evict to use Hibernate's term. That object is no longer in the session because it was pending and we didn't find it, and it's out. So the rollback has basically totally cleaned up the state both at the database side and on the Python side. And that's why auto expiration is kind of a nice thing. The data is also, of course, gone from the database. So we run that query, we don't get fake user back, and we get SpongeBob's original name, even though he still has that SpongeBob Jones name. That's transactions. Because I want to get through things, I'm going to jump right into the querying part because the next section is about querying, because querying is really where most of the fun stuff happens. Again, with querying, we have this idea of the column object and the overloaded expressions. So user.username equals SpongeBob. Again, gives us the user.username is kind of a quasi-column object. It's not actually a column, but there is a column inside of it. And notice I'm querying from the user. So this is the user class. The user class has this table. Okay. Username is this thing called instrumented attribute, which you don't need to really know about, but just know that it acts like a column. Oops. The column is actually in there. If you do that, there's the column. That's actually mapped to the table. There's actually more weird things about that column that I don't have time to get into. Anyway, user.username acts like a column on the database table, the way we had table.c.column. Why isn't there a .c attribute? Well, a long time ago there was a .c attribute, but the reason we don't have .c is because your user class is your user class. Your .username attribute is your .username attribute. There's no reason we'd be concerned about .username overriding some other name on the user class that we need, because that is the name. When we have a table object and we say table.c.user, that's in case your table name is, if your column is called insert, table.c.insert is different from the table.insert method. So the .c thing has to do with naming. When you're in the ORM, there is no .c attribute. It's just your class dot the name of your attribute, and that acts as a column expression. So again, like before, the query object acts a lot like a select. So we can say, give us user objects, except in this case, it's giving us user objects and not database rows. This is the way the query was first written, was that it did not return rows at all. It returned just objects. So when I say query user, order by user ID, give me all, it's going to give me a list of what I asked for, and not as a row, not as a tuple, but as the actual instance of the user object. Later on, query was enhanced so that it does return a tuple-like row. If you ask for multiple things from query, like individual columns, you will get tuples back. These tuples are different from the rows you get back in core, However, in 1.4, they're now the same kind of row object. So you get the same row object back from this query in 1.4, just out of the gate, as you do in the core, which acts like a tuple, so it's pretty good. There's your tuples. And you can also query for combinations of multiple classes if you want. We'll show that later, and columns. So I want to give a row where the first element of the row is the user object, and the second element of the row is the string username. So I get the user objects back and the string names. Check the time. Okay. You have a where by you have a filter by clause, which is kind of like a shorthand to the where clause. You just give it key value pairs. And the keys, I'm trying to, sorry, digestive. So the keys are coming from the attributes that are named in the class. You can say filter by, convenient. If you want to do full-blown expressions with ors and ands and whatnot, you can use filter, which is oddly enough named differently than .where. That's also a thing that I hope 1.4 fixes, because why do we have two objects to do this? Anyway, in current ORM, the ORM everyone knows and loves, it uses .filter for ORM where clauses. They act just like the where on the select. A variety of returning results is I can get all for a list. I can get first, which gives me just the first row as a single object, or none if there's nothing there. And then there's the one method, which is pretty popular. One will give you that same value as first, but if there's more than one row or 0 rows, it'll throw an exception. So here's one, there's one object. If I do give me no rows but one, oh, I get an exception. No row was found when one was required. If I get more than one, give me all the users, but just .1, that's wrong. Multiple rows were found, that's what .1 does. .1 is still around in SQLAlchemy 1.4. It's now present on that new result object. So you can use .1 for core results as well, which is kind of a new thing. So that is the basics of what does the session do, how does the session do transactions and expiration of objects, because that's like a big deal. I actually have a whole talk about that. And then what does the query kind of look like? So that's the first part. The next section is all the more advanced query stuff. What's the difference between filter and filter by? Good. So filter, do we have a session here? Filter accepts an argument that is of a type called binary expression. So if I say expert equals user name equals foo, expert is this object called a binary expression. Q equals session query user filter will actually take positional arguments. It takes basically Python positional args like that. You can pass it expert, and that is what it is going to use. Now, if I were to pass expert twice, I think this would work. It'll give me the same thing twice. Let's say from user where username equals and. So basically, filter from a Python point of view is accepting args, right? If that makes sense for people who know Python pretty well. Filter by does not accept args. Filter by accepts KW args. So when we have this expert object up here, we cannot pass that. Oh, sorry, I wrote the wrong thing. Filter by takes KW args. Filter by will not accept this user and username thing. It does not want to have a binary expression object. It wants us to just give it the name of any attribute on user that we care about, like username equals foo. And then we also want to say full name equals bar. And notice we're not using the double equal sign because we're not passing a binary expression object. We're passing just Python name, keyword, name, key arguments. What filter by will do is it will create for us behind the scenes this binary expression. So when I do this and I print Q2, you get the same thing. Does that answer the question? Good. But you're not typing fast enough. I assume the question is answered. Okay. So that is, yeah, I'm a little late. For the advanced section, just like with the SQL Advanced, we're now going to talk about two tables, and we're going to do about joins and relationships. And in the SQLAlchemy ORM, when you're dealing with more than one table, a lot more is going on than goes on with the. One more question: does EQ not return a bool? Trick question. It does and does not. It's not actually a bool, but it has the bool method, so you actually can call bool on it, and it will actually do an equals. But it's not that very performant, so you got to be careful. Yes, the bool thing has been a big deal, but it does have a bool on it, so it will actually give you a bool compatible object. But I don't recommend using it that way, because you don't have to. So let's do the same model again, except we're going to have user and address, as we've hopefully have seen many times by now. We're going to use this new concept called a relationship, which means that we're not only going to have user and address have a relationship by a foreign key, the ORM is going to have additional directives which say, hey, I need you to also persist the related address objects in the collection. And as you do that, I also want you to synchronize what I'm doing with an attribute on each address object called .user. And that's what the backpopulates keyword does. People will know this more as a keyword called backref, which is much more well known. Backref is not going away. It's still there. It's great. I find backpopulates to be clearer. You can still use backref, no problem. But just I think backpopulates might be a little easier to reason about. Now we have an address class, which also has a relationship. Says address, hey, I'm going to have a relationship back to this relationship called user. And when you populate or deal with my .user attribute, also please maintain the collection on that user object called addresses. Notice this does not escape us from the responsibility of creating the foreign key element also. This is the part where SQLAlchemy is very separate in how the ORM mapping and the core DDL systems work. They're very separate. There's a big firewall between the core table DDL stuff and the ORM. So in some respects, you have to tell the ORM twice. I like to say it's being explicit. There are ways to automate these foreign keys, but they're just complicated. And I think in practice, people like to deal with their database models in both ways. They want to see how it's going to live as the DDL in their database. And then separately, they want to see how it's going to act in Python. And those are two separate concerns, so they're pretty separate. So let's, again, go back and do the metadata create all thing that we're doing. And we get user and address like we had before with the foreign key. Nothing is different there. Then let's put some data back into the table the way we did before. We make some objects and we add all, and then we say commit. Unit of work commits those objects. The fact that you see 3 separate insert statements is also a detail of the fact that we want to get the primary key value generated from SQLite and returned. If we were to give these objects a primary key value up front, it would have used an execute many in one step, kind of an implementation detail. Let's make a new object for Squidward, and don't add him yet. When we make Squidward, he now has, kind of like the way SpongeBob had an implicit .id, Squidward has an implicit .addresses, which is a collection, and it's empty. That's because we made a relationship on user called addresses. So every user object now has a thing called addresses, which points to a list. It's a Python list. It has, again, has special instrumentation on it, but it is a Python list. You can also use a set. You can also use a dictionary with some extra steps, and you can use a custom collection. By default, it is a list. That list is also not part of the state of Squidward yet. That list is a little default list, and it will not become part of Squidward state until we modify it. Let's modify it, specifically by replacing it with another list. We could also append to the list. We can append items to the list. If it were a set, we could add items. So let's add 3 email addresses for Squidward has a lot of email addresses. So we're going to have 3 emails. And when we do that, if we look at one of those address objects, the address object here, AD equals Squidward addresses. Do this. That's an address object. It's inside of Squidward's addresses collection. It has .user pointing back. And this is basically the one-to-many, many-to-one thing that the back populates has done for us. By appending address to Squidward's .addresses collection, the back populates directive said, oh, also set the .user on that address back to the user object that we're populating. And also, when we add Squidward, the user object, to the session, there's a behavior that comes from Hibernate called cascades, which means it's going to cascade to all the child collections and attributes on Squidward to also add all those other objects to the session automatically for us, because usually that's what you want. There are ways to change cascade, but in practice, nobody ever does, at least at that level. Commit all that data. So now we get Squidward and the addresses. And also, a thing that the unit of work does here is that it makes sure that it inserts Squidward first. It gets the new primary key for the Squidward row, which is probably number 3 here. Gets that number back. Oh, actually, number 4. That's right there. Gets number 4 back. Makes sure number 4 is populated into the user ID column of the address rows. And that's one of the things that ORMs do for you, which is they take care of all the messy business of whose primary key is what, which foreign key gets what primary key. That all gets taken care of for you by the ORM and the unit of work, which makes sure the statements are invoked in the correct order such that you don't get an integrity violation, which is very neat. And that's the big advantage of Data Mapper over Active Record. We've committed, which meant, again, everything is expired. So when we access the .addresses collection, once again, lazy load will do this thing where it's going to load. First, it's going to refresh the Squidward row itself because it might have been deleted. And then it will go and say, hey, give me all of the email addresses that are associated with this Squidward user. You could see the where clause, where 4 equals address user ID, and you get back all of Squidward's 3 email addresses. And a thing that SQLAlchemy does that not every ORM does is that this is a plain Python list that has now been populated. If you talk to Squidward.addresses again, it's just there. There's no SQL omitted. It just goes, oh, okay, well, that's the list, and here it is. I'm just sitting there. Some ORMs will run SQL every time you access a related collection. SQLAlchemy does have an option to do that, but it's not usually used, and you don't really need it most of the time. Let's do something where we're going to mess things up. We're going to take one of Squidward's addresses, and we're going to change the .user attribute to point to SpongeBob. So basically, SpongeBob is going to steal one of Squidward's email addresses. And we're actually going to load SpongeBob from the database. I'm going to, just for the purpose of example, hit SpongeBob's addresses collection, which will lazy load by default, so that we can see where that's going. And then Squidward.addresses, his second address, we're going to say Squidward's second address, change .user to be SpongeBob. What's going to happen? From a relational database perspective, each address row can only point to one user at a time. So it has to change ownership, meaning it has to be removed from Squidward's .addresses collection, and it will be moved into SpongeBob's .addresses collection. And so what you see here is the SQL you see is the SpongeBob record being loaded, and then SpongeBob's currently, I think, maybe 1 element addresses collection being loaded. However, the move of Squidward's address record has not been persisted to the database yet. When we look at it, SpongeBob's addresses now has Squidward's email address in his collection, and Squidward's addresses has lost that email address, and that has not been persisted to the database yet. This is just the Python back populates keyword doing its little thing of moving things around in response to the other side. Now, this is automatic implicit magic behavior. You don't have to use it. If you don't like it, you can turn it off, and there's actually even more options now to turn off this syncing feature, but in practice, nobody ever does. Everyone pretty much loves backrefs 100% of the time with no problems whatsoever. Okay, so we've changed the state of the Python collections, and then when we do a flush or a commit, it will express those changes in the database. And you can see it's really quite short. All it did was update the user ID column of that row to point to SpongeBob rather than Squidward. Set the user ID to point to 1 instead of number 4. So people are asking questions as we go. So I'm gonna keep going until I see. Querying with multiple tables. Okay, slide 10. Okay, so he's referring to the way you see this word cached. Now, the thing about cached is I haven't talked too much about that, but when you see in the SQL output, you'll see the word generated and you'll see the word cached. When you see the word generated, it actually says generated in. That means how long it took to generate the query. When you see the word cached, it says cached for. The time is now how long has this thing has been cached for, because it wasn't generated. So there's no time for generation. Yeah, I know. It's in the docs. I'm going to document it. This is all new stuff. And yes, being confused about that is something that I have to see. Maybe if it's too confusing, I'll change it. I wanted the caching logging to show how long something's been cached so that you can see if your cache is swapping too much. That's basically why it shows how long it's been cached. So because if you see things are constantly cached for a very short time, that means your cache is too small and swapping out too often. So I wanted people to see that. The difference between flush and commit is that flush is going to push data out to the database by emitting insert, update, and delete statements. And commit is going to just call commit. They're two separate things. However, when you commit the session, it automatically does a flush for you. So the commit is kind of, the commit of the session includes a flush for free if you have to do a flush. So first it will do the flush step, which is the rows going into the database, then the commit, which is commit the data and expire the current objects. This is an example of querying with multiple objects. This is the part where I start talking really fast because we have, 20 more slides. You can query multiple objects and get tuples back. This is what I talked about before, the implicit join of user ID equals address ID. And in the from clause, you see the commas. You can then also do join, as we showed before in the SQL tutorial. There's a join. I can join from user to address. You get a join. I can also join with an explicit on clause. And the select version does this too. Join to address and make sure you use this specific on clause of user ID equals the address user ID. And the best way to join with the ORM is to join on the relationship. So another reason we made this user.addresses thing is that when we refer to user.addresses at the class level, we can send it to join so that suppose user and address had multiple foreign keys and multiple relationships and multiple ways to join, it would be ambiguous to know how to join these two things. Yeah. So we can use the relationship to do that. So basically at this point, we're in the 10-minute warning, which means I didn't talk too fast to kill my throat. That's a join relationship. I want to show you eager loading pretty fast. So let me go through a few things. Here's aliased for the ORM. It works a lot like the alias that we saw for the core select. So it's the same kind of thing, except that we can alias against an entity. We can join to alias using this thing called of type, which is in the docs. We can do subqueries like we did before. We showed subqueries with core. You can do the exact same subquery with the ORM query. So here's an example of the addressing, counting the addresses for each user and getting that back. So again, using the ORM is in many ways just like using core. Next section, eager loading. So here's the thing when you read about ORMs, why you should not use an ORM is they'll say the n+1 problem means because you were lazy loading a collection, if you load a lot of objects and then access all the collections, you get a lot of queries. So if I load all the users and hit all the addresses, you get lots of queries. And it's slow. Eager loading means that I can tell the ORM, hey, load all of these collections in one shot for me, by the way, because I'm going to want them. So the best eager loading you can use for collections in modern SQLAlchemy is called select and load. This is the options version that you do at query time. You can also set it up at mapping time. So query user options select and load user addresses is going to do a second query that is an in query. You see it selects the username, and then it does a second query against the addresses table, and it gets all the primary keys that it loaded for users and puts them all in the in clause. And the reason select and load is the best eager loading is because it doesn't use any joins in a simple case. It doesn't use any joins, no outer joins. It uses one table, and it uses a primary key index lookup. So it is the fastest eager load that you can use for most purposes. It's not always appropriate for some reasons that we don't have time to get into. The oldest loading we have is called join load, which is where the ORM runs one query and does a left outer join or an inner join. Join loading is what everyone knows because it's the oldest joining. I thought was the only one we needed a long time ago. Is very good for many-to-one loads because it only has your parent row plus the many-to-one. So if we want to load address objects and also eagerly load the user object, we can do a join load, and we can also say inner join equals true. So meaning we don't need to use an outer join for this one. You can get that. If you want to do an explicit join, that is kept separate from what join load does. People that work with SQLAlchemy know this pretty well. So if this doesn't make sense to you, if you work with SQLAlchemy, you'll get it pretty quickly. Join to address user and then also join load. They're separate. You get two different joins. That seems weird. Why do I want that? I don't want that. I actually want to join and also load it. Okay, there's an option called contains eager that will both join explicitly to that table and also contains eager, apply that object to the address user relationship. And that is eager loading, which was the fastest eager loading ever. And if eager loading is new to you, that was way too fast for you to understand it. So just go to the docs. And everyone uses eager loading all the time. I know everyone can learn it. It's easier than other things. And the final section is a little bit of the 2.0 stuff. So I have 7 minutes, right, for 2.0 stuff. Is that good? Yes, I see nothing happening. Good. I have no idea. How many people are on this session? Can someone type in the thing how many people are here? Because I see only 3 people on my screen. Are there 10 people?
Yeah,
or-
so in the Zoom you have 22, but on the actual Cloud Swarm, there's probably another 20 or so.
Oh, okay. So it's okay. I wasn't sure if it was like 100, 200 people. Okay, good. What's new in 1.4.2? So let's look at that future select thing pretty quick that I just said will actually work like the query, and it does. You can have your future select, and notice when you make the future select, there's no more brackets here. You send the columns and entities that you want to query positionally, and then you can do a join just like the ORM does a join. And the way that this is stays cool with the fact that this is the core and the core knows nothing about the ORM is that the way the statements work in 1.4, it's just going to gather these arguments and do very little with them. It's not really going to know much about them. It's going to do a thing called a coercion, which will introspect into the object given, and the object will say, hey, I'm okay, I'm good for join. When I get compiled, this ORM will handle me later, and it'll all be fine. So even though you're core and you're nothing about ORM relationships, don't worry, I'll be used later. I probably should think of the name of that architecture. So future select user email address, join the user addresses, and then we execute it with the statement. We do session.execute, which is different because if you notice the ORM query is about session.query user whatever .all.1. That's what the query does, but people wanted there to be more flexibility with how to get results. So by using execute, we get a separate result object, which is the same exact kind of result. Well, it's actually a subtype that you get with core. So you can work with core results and ORM results pretty interchangeably, and you won't even really know which one you're dealing with. You'll just have database results. You don't have to care how you got there. So this is a select statement that when you run through the session will actually load user objects in the result. So when you have the result, you then say, hey, I just want the first row as a scalar, and also can you please uniquify them for me and give me all of them? So this is called method chaining on the result, which is totally new in 1.4. That's not in 1.3 at all. So I get back my users. So it's a more longhand API. It's more explicit, but I think it's much more clear, and I think it really we'll have to deal with how people might not like the verbosity, but it's much less ambiguous, and I think it's easier to understand, and I think it'll be popular, but we're waiting to see how people comment on it as people look at it. Also, select is now can just replace query. There's no longer filter. There's no longer filter versus where. There's just where. However, select does have filter by now. So you still have your filter by, which is handy because people like that too. So you have filter by, where, and dot join that are equal across both ORM and core There's no more need to learn both APIs separately. They're both the same API now, except with the ORM behaviors. You get that. And what are we doing here? Yeah, here's the caching. So here's an example of a statement that we just ran with the core connection. And it said generated in 0.00056 seconds. So now this statement is cached. When I run it in a totally different context, in the ORM context, in this particular case, it's still going to be cached. And the longer I talk, the bigger the number is going to be because it's showing how long it's been cached for. So if I speak for 10 seconds, I speak for 20 seconds, I'm going to say it's about 35 seconds. And when I say run code, oh, wow, 34.48 seconds. I must be a drummer. I am a drummer. So that was cached for 34.48 seconds, which means that my brain works to an accuracy of half a second. So that was cached, meaning the whole lot of work that the ORM especially has to do to make this join. There's a lot of stuff it does internally to do eager loads, to figure out what attributes are going to load. There's all kinds of Python computation. That entire thing is now cached. And SQLAlchemy 1.3 has a feature called baked queries, which do this. Baked queries work really well, but they're hard to use. It's now a little not quite as fast as baked query, but it's almost as fast, and it's transparent. It just happens for you for every query. So people's applications should be a lot faster because there's no more need to use baked query. You'll have the caching everywhere it can be used. That's it.